our distinguished speaker, Professor Vanu Gopal Achanta, who is Director NAPL, to be here with us. And now mic is over to, please.
Professor A. Venu Gopal did his MSc in physics from Central University, Hyderabad. He obtained his PhD in physics from Tata Institute of Fundamental Research in 2000 for his work on exciton dynamics in low-dimensional semiconductors. In 2006, he was awarded PhD in electronics engineering from Tokyo University for work on design and demonstration of an ultra-fast all-optical switch. This work was done as a NIDO fellow at the headquarters of Japanese National Femtosecond Technology Project FESTA Labs between 2000 and 2003. From 2003 to 2004, he worked as JST Fellow in the Quantum Information Technology Group, Basic Research Labs, NEC, Japan. He joined TIFR as faculty in 2004, where he had been professor since 2018. His research interest is in classical and quantum information processing with dipolar emitters like quantum dots embedded in photonic and nanophotonic structures. He represented India in the first BRICS Photonics Working Group meeting, which prepared recommendations to BRICS Ministerial Meeting, Moscow, 2018. Professor Venu Gopal is currently the director at CSIR NPL from June 2021. It is our privilege to have him with us today. And over to you, sir.
Something she missed. Professor Venugopal is a director of NPL. There are a few things she missed. The NPL is known for its standards, and it is like National Bureau of Standards of India. In your daily life, you right from housewife, they have pressure cooker or two-wheelers, how much pressure is involved in each tire, PSI, pounds per square inch. Everything is very accurately monitored and calibrated at National Physical Lab. The first director was Professor K.S. Krishnan, who was student of C.V. Rahman. He came from Allahabad to lead NPL. Of course, he was supposed to share the Nobel Prize with C.V. Rahman. And NPL is very well known in social sciences also. The reason where whenever you go for casting your vote, you have indelible ink in your finger. That ink is developed by National Physical Lab. So it speaks about the democracy. For Indian democracy, NPL plays a major role. Second, Dr. B.R. Ambedkar wrote Constitution, but the Constitution even now is preserved by only National Physical Lab. What else you need? And now Professor Venugopal Achanta is the director of National Physical Lab, and under his leadership, NPL is doing very well in force standard, pressure standard, vacuum standard, temperature standard, atomic clock, gravity standard. Name anything, the standard means we have to look upon NPL. And more importantly, NPL is the institutional membership of Indian Social Science Academy and Professor Venugopal. And I am very happy to introduce him as a fellow of Indian Social Science Academy. Please, sir.
Good morning, and yes. First, I should thank Professor Parthasarathi and all the Indian Science Academy for giving me this opportunity to be here, and Professor Harinarayana, the registrar, and the Crescent team for organizing this congress and for the local hospitality. Thank you very much. Right. So, as Professor Harinarayana, Professor Parthasarathi has mentioned, we all would have heard about NIST in US, right? So you talk about standards in the world, like we remember NIST, right? So we want a reference material, we say like, let's have a NIST standard. We buy some very fancy scientific equipment to calibrate it or something, we say, okay, let's get a NIST standard, right? So what I'm going to talk about today is the metrology. Metrology is the science and art of doing high precision measurements. Right. So thank you. So how NPL, the National Physical Laboratory, which is the National Metrology Institute of India, right? So every country has a designated metrology institute, right? So like NIST in US, which most of us know, NPL is the standards institute or the metrology institute for India, right? So the what I'm uh, trying to cover here is what we have done in the past, right? The NPL, why it is known. So uh, and then like so what we are doing now for the future, right? So when we talk about NPL, those who know, the seniors, like so Professor Partha, they already mentioned the indelible ink. So this was made and technology transferred to Mysore Paints, and Mysore Paints make this for every election. The indelible ink is made, right? So when people talk about NPL, people remember about indelible ink, and some of them remember uh, the NPL as timekeepers of India, right? Those who are Marvel fans in the students, so you can see that this is expected the timekeepers, right? So the Indian Standard Time is maintained as Professor Padsad mentioned. Like so, uh, we maintain the atomic clocks, which we compare it with the international time, the BIPM standard, so which sets this. Now we are off the GMT. Now we call the Universal Coordinated Time (UCT), right? UTC. So the UTC is done by getting the time signals or time information from a large number of countries, and then the UTC is maintained all over the country. So the IST is maintained, and the information is shared with the BIPM through NPL, right? But NPL has lot more than just a timekeeper or the indelible link. So that's what I will try to convey to you in this talk. This year is especially significant because we all hearing about this 75 years of independence, or the 75th year of independence, as the Amrit Mahotsav. This is also CSIR, the parent organization of NPL, is celebrating its 80th year. And incidentally, NPL itself just completed in January 75 years, right? So as I mentioned, NPL, this is for the sake of students to introduce what NPL is. NPL, by an act of parliament, is declared the National Metrology Institute of the country, right? So there are also now we also take care of these environmental standards. Then we also look at the time standards and other things, right? So in the old times, right, till about 2019, what do we call about mass standard or the length standard? What is 1 meter? What is 1 kilogram? How do we know that? Right. So I'll tell you how this whole thing works in the country. When Professor Parsad mentioned about pressure, right? Pressure standard. What is how much pressure is there in the tires, right? Well, how many psi? 30 psi, 32 psi. Like how do you measure that? How do we know that it's actually that? So initially it was all prototypes which were there, artifacts. This was platinum, iridium alloys which are used to um, give as a prototype for each country. So ours is called the NPK National Prototype of Kilogram 57, and our length has copy number 4, which we got from BIPM, and we maintain it. So we make copies out of these, and then we distribute it to other organizations within the country, right? So if we talk about metrology and the country itself, let us go back to really old times, right? We must have seen this kind of structures in hills all over the country, right? This is a cave, right? Doesn't look very high precision. It just something chiseled into the hill and made a small hole in the cave. But what about this? Right. So if you see this, there are two floors in this hill, and there are pillars, and then there is windows here. These windows all look of similar size and shape, right? Not much interesting till we say that these are not made 100 years ago, 200 years ago. These are from Udaygiri caves in Odisha, which are from first BC or so, right? So about 2000 years ago these were built, right? So if you are not still impressed, you can go back even further. So this is from 7th century BC. This is from Nalanda, Bihar. If you see these structures, if you just zoom in the corner of this area here, right, you see what we see is bricks which look almost of uniform size, right? And using them, they're nice shapes, right? Very nice shapes. It's just not simple cylinder or simple square or triangle, but it's a taproot structure, like so with very nice dome-like structures and all that. These were all built almost 3,000 years ago, right? So we do have precision measurement way back. So there are measurement tools in the country thousands of years ago, right? So this is an artifact, this is a conch shell on which you see these gradations, right? So this is the length, this is like our modern day scale, right? So these are weights which are well known over many centuries ago, right? In the Hindu literature or Indian literature, we do see that the time standards, the time is going from 10 power 22 seconds to 10 power minus 7 seconds. All these things are very well precisely known in the literature, right? Weights and measures, this is from the Kautilya's books, Arthashastra, for example. So he has described 16 different types of balances. So this is one of them, which is known as the Roman balance currently. So this is a scale which is from the Egyptian Egypt. So it's called an Egyptian cubit rod. This is very well preserved, and most of the museums around the world have these scales, right? But unfortunately, we do not preserve our own measurement tools of the past, right? At some point, when we had these measuring tools with high precision, so we went into anarchy, right? Even now we use this qubit, like, so especially when we want to buy flowers, like, so the guy just measures like this and sells you off, right? So there is some bit of anarchy. Different regions in the country, different countries are using different ways of measuring, right? So it went all went into some kind of disintegration or confusion over the measurements. So in 1800s, the first time the French developed the decimal system, and they also came up with definitions for the length and the weight. For example, the length, they said 1 meter is equal to 10 power minus 7 times the length measured from North Pole to the equator, right? If this distance is 10,000 kilometer, which is approximately correct, right? And 10 power minus 7 times gives you 1 meter. And kilogram is given as 1 cubic decimeter of water, right? Now, how do you measure this length from North Pole to the equator very precisely, and then find 10 power minus 7 times of that to get 1 meter definition, right? It's a very cumbersome process, and we need different ways of having these standards. So that's how this BIPM, which is international organization, the Bureau of International Points and Measures. So this was started, and under this we have these national metrology institutes, for example, NPL India, NIST, NPL UK, PTB Germany, and all these countries have these. And then under each of these NMIs, you have these regional reference standard laboratories, right? So basically, BIPM gives a copy of these references to each of these NMIs. NMIs maintains this and then makes copies of them and gives to these RRSLs, and RRSLs in turn gives them to the local industry or shopkeepers and all those people. So that's how the entire metrology scheme works in the country as well as in the world, right? So the important point is there is a traceability. Whatever we are measuring in the shop when we are buying a cloth for 1 meter, right? That 1 meter is same as a 1 meter in I don't know, Nicaragua or in US or in Timbuktu, right? It doesn't matter where we use, that 1 meter is always traceable. Why is it important? Because when we are exporting, right, our industry standards need to be at par with what world will accept. So the traceability is very important, and um, that's where the I mean the chain is important. That, like, there is a National Metrology Institute, and through which we get the primary standards maintained. Right, this is a brief history of metrology. So 1946 it all started with the establishment of Indian Standards Institution, or the BIS. 1947 NPL was established, and then 1956. So okay, these all just dates, but the important thing is now what do we have in the country. So we have, for example, there are 7 SI units. The standard units are length, mass, time, current, temperature, luminous intensity, and amount of substance, mole. Right. So what do we have in the country? We have 1 meter with an uncertainty of 2.1 into 10 power minus 11. So that's about 21 picometers. We can measure 1 meter with picometer uncertainty. We can measure a kilogram with nanogram precision. We can measure second with nanosecond precision. So actually with the cesium atomic clock, we can get about 100 femtosecond time resolution or uncertainty. So this is the kind of facilities which we have in the country. Right. So as I said, so we start with the SI units, then we have the national standards which are maintained at NPL, and then we go to the primary standards, working standards are made and then dispersed to RRSLs, and then which they make further to the shopkeepers and others. Right. So this is the same thing to show that, like, so we start with the international organization and then go down to the um, to the NPL. So within the international organization structure is that, so the world is broken into 6 different zones. So we come under this Asia Pacific Metrology Program. So whatever standard we keep in the country at NPL, so it's always compared and scrutinized, inspected by the inspectors or evaluators or assessors from the APMP and BIPM organizations, to make sure that our standards, what we are claiming, are at par and acceptable to the rest of the world. Right. So at CSR NPL, so what we do is we interact with the international organizations, the CGPM, BIPM, and all these organizations. So we realize and define and maintain these primary standards for the country, and then we also help provide the traceability to the industry. We train people, students as well as other organizations, to maintain the quality infrastructure and standards in the country. So at NPL we have 7 different divisions. In the metrology, it's basically split into 6 different standards. So one is the time metrology, the physico-mechanical, the electrical and electronics, environment and biomedical, materials and device metrology, and the reference materials under the Bharatiya Nirdesh Yatra. Right. So as I said, so whatever we do, when we have a standard, it's always compared with the rest of the world. And then, so it's the same sample is sent to multiple countries, and everyone measures that the same sample, and then they use their own analysis methods and get the value, right? And at the end of it, all the countries will compare how much value each country got, right? And then they plot it, and that plot is called the intercomparison plot, right? For time, so for example, USA has the best one with 2.1 nanosecond uncertainty in the time. So we are pretty good in the world with about 2.8 nanosecond precision, which we have for the country. Right. If you look at temperature, for example, so we the best is about 60 microkelvin, right? From NIST USA, what we have is about 100 microkelvin. Right. So if you look at voltage, we can measure 10 volt voltage with 60 nanovolt precision. Right. So the best in the world is 40 nanovolt, which is the record is held by Korea. Right. If you look at quantum Hall resistance, we can measure 1 kilo ohm resistance when in 80 parts per billion uncertainty. Right. These are the intercomparison plots for force, and this is for the pressure, just to show that NPL India is very much at par with the rest of the world, and most of the time it's in the top 10 in the world. Right. This is for the ultrasound power, and if you look at how we propagate these within the country, so this is the sector-wise metrological services which we offer. So for example, testing labs. So there are these NABL accredited labs, right? If you go for testing of, say, medical pathology, I think so we all talked about NABL accreditation is there or not. So that means there is certain standard which is being maintained. So that standards are coming from, the traceability is coming from NPL. So all the equipment has to come to NPL. We calibrate, we certify that yes, this is uncertainty, this is the testing capability of this equipment, right? So the sector wise, from testing labs to defense to space, we provide services to all of them. Right. So this is state wise. So what we see is because of the proximity, Delhi we service more, but there are also states like Bihar and all that, like which we need to pick up. So this plot also shows where we need to improve the quality infrastructure, where the industry in the country needs to be improved. Right. So as I mentioned, we are the timekeepers, not just timekeepers. We also are mandated by the Parliament as a National Metrology Institute. So we work at future uh, uh, of the metrology activities in the country, so that like we set up these quantum metrology standards that are globally competitive. We have these primary 7 standards: the kilogram, meter, second, ampere, Kelvin, mole, and candela. And we also work on developing these reference materials known as Bharati Nirdeshak Dravya. And in addition to the standards, NPL is also known for 2 other areas. One is material science for basic and industrial research, and environmental sciences for weather, ionosphere models, and monitoring stations across the world. Right. I'll show you some examples of NPL over the past 75 years. Right. So for example, if one most of the younger generation won't know about a black and white TV, but the monochrome black and white TVs, the phosphors were first made at NPL, and then the technology was transferred to Bell and Samtel in Ghaziabad. Right. The first synthetic diamonds, industry grade synthetic diamonds, were made at NPL. Right. So the indigenous crystal pullers, if you want to make single crystals, so this was the first single crystal Sekrolsky setup, which was made in the 1960s. Right. So this is a soda which was developed in 1973. So in since 1960s, NPL is one of the regional warning centers for International Space Environment Services of ORSI. So this is one of the 20 centers around the world. Right. So a master control facility of ISRO was also set up in 1980s to track satellites here. Right. So CEL, so there are a lot of these electronic components like capacitors and all that. Like, so they were developed at NPL, and then the Central Electronic Limited (CEL) at Sahibabad was set up in 1974, which is an offshoot or as a spin-off from NPL. Right. So as we also provide services to regional reference standard laboratories, for example, at the request of RRSL Varanasi and Ghaziabad, so we made these BP monitoring stations. So where at a time, like, so 20 BP equipment, blood pressure equipment, as well as thermometers can be tested in one go, fully automated system. So with the complete reports can be generated. Right. So we can we provide these DC high voltage testing facilities for all the electrical industry. For example, these power stations and other things. So we provide the calibration and testing services. Right. So as Professor Parsad mentioned, like, so we preserve the Indian Constitution. We have the Hindi and the English handwritten constitutions which are preserved in the Parliament Library. So these are preserved so that they don't get destroyed by the environmental conditions. Right. So these are the Bharati Nirdeshak Dravya. We make different chemical, water, for example, rice, cement, right, oil, gold purity, reference materials. These are all made at NPL. Right. This is a spray forming unit which is developed at CSIR NPL. So this is basically for aluminum and magnesium alloys. These are used in satellites, for example, INSAT PSLV and Advanced Light Helicopter. So these are rods for that. This is a carbon-carbon composite developed for Agni missile. So the top cone is made of this composite which is developed at NPL. Right. This is an XRD 5 crystal XRD instrument which was developed at NPL. is superconducting magnets which were made way back in the 1980s at NPL. So these are routinely the knowledge is with IUAC and other places in the country now. Right. So this is the My 3 station at Antarctica, a weather station with SODAR, where continuous monitoring happens for weather monitoring and how the changes happens at these locations. For time, we have a bank of cesium clocks and hydrogen measures, and we are also trying to revive this cesium fountain, which is one of the unique facilities across the world. Right. So we also recently released these biomedical device standards. These are calibration facility for defibrillator. So this is the setup. I mean, these were dedicated to the nation by Honorable Minister Dr. Jitendra Singh in January. So this is also, I mean, another calibration setup for infusion pump was also set up now. Right. So for environment, this is a PM 2.5 samplers. This is a wind tunnel facility for calibrating these particle matters of 2.5 and 5 micron size particles. Right. So these are carbon composites for these were, I mean, mostly used by polio patients. So these are Elizero fixators. These are carbon composite fuel tubes for compact nuclear reactor. Right. So these are carbon paper for fuel cells, right? So these are color shift pigments which we see in 500 rupee note, for example. So different colors, if you shine, like so different colors are reflected or the emission will be different. So these pigments are also developed at NPL, right? So we also have strong team on converting plastic waste to wealth. The solar cell waste is also converted, extract all the precious metals and the recycled silicon. With that, like we are trying to develop silicon solar cells. The agri waste is used for particle boards and other things. So this is another very important thing, which is the only second in the Asia. So what it does is it's a carbon dioxide enrichment facility. So in the local area, so the carbon dioxide content can be controlled so that we can study how the carbon dioxide is going to affect the crop yield, right? So this is another remote atmospheric monitoring station at Palampur, right? I think I'm giving too many things. So for COVID, we have a PPE kit calibration testing facility, and this is again for rooms like this. What we have is a UVC disinfectant unit, so which is shown here, for example. So the air inlet is from the top, and then it's released out. So there are two tubes of UVC lamps, so which are calibrated, tested, and all certified for antiviral, antibacterial, electrical safety, all these things. So this product is in market right now, right? So that is for the past and the near past. So what are the ongoing projects? What we have is, for example, we have Government of India has this Ujala Yojana where LEDs are promoted quite a lot. So, but LEDs are, the chips are imported from outside, and then all that we do in the country is make the electronics and then the outer bulb and shell and other things, right? But what is the quality of the LEDs which we are getting? Right. So for testing that, like we have a LED testing facility now. We are setting up these atomic clocks at 5 stations across the country, so that we have the secondary standards for the time, so that this is important for ISRO and as well as for defense applications. So we have this testing and calibrating pollution monitoring equipment. So this project is ongoing. So we're also setting up the photovoltaic primary standard, where we can measure any type of photovoltaic cell, and for their quantum efficiency, for their durability, how long lasting they are, and all that. So I'll briefly talk about these single photon detectors in the next few slides, right? So our focus is currently in 2019, the definitions have been changed. Now all the SI units are now linked to the fundamental constants. For example, time to the atomic transition between two energy levels in an atom. The mass is related to the Planck's constant. The mole, of course, is related to the Avogadro constant. Like that, like every single 7 of those SI units are all linked to the fundamental constants. So these are known as the quantum standards. So we are looking at setting up these quantum metrology standards in the country. Right. So this is the LED metrology facility. So here we can do complete photobiological safety testing of light source up to 50 meter size LED lamps. We can calibrate and test them in-house at NPL. Right. So I'll move on to this quantum related things. So one is my own research work is on generating non-classical light sources for single photons. For quantum communication, for example, we have to transmit single photons into the in a fiber or in the free space. But can we have, how do you generate single photons from any system, right? So the idea which we use is the so-called metamaterials. So the metamaterials are man-made materials which do not exist in nature. We can design them and for a particular application, and we can make them. So the only condition is that we can the smallest feature which is repeated, for example, like an atom in a crystal. So the unit cell is much smaller than the wavelength of the light for which it is designed, right? So we use such uh, um, materials to extract a photon, a single photon. For example, the light which is coming from this tube light, for example, is having 10 power 15 uh, kind of number of photons. So from that we have to come down to one single photon, right? So what we do is we design the structures so that um, we have a single nanoparticle inside a layered structure of metal and insulator, right? And this material is designed in such a way that the local density of states are will help any photon which is emitted from the quantum dot or a nanoparticle to come out into the neighboring region. And from that we put an antenna on top. This is just a simple patch antenna, so that the photon is emitted coupled to the free space in a particular direction. So that's what is shown. These are the simulation results where we can get the photon emitted in about 10-degree outward direction, right? So we actually made these structures and showed that we can get 200 times enhancement in emission and 40% collection efficiency of photons from these structures, right? So one of the things which is important when we are making these structures is when we're talking about single photons, every single photon which is coming from the background noise has to be taken care of, right? So when light is incident on a nanoparticle, the photon is absorbed, electron is exited from valence band to the conduction band, and that excited electron recombines with the hole in the valence band and emits a photon out, right? We know this photoluminescence or fluorescent, whatever we call it, right? So it's the electron recombines with the hole and emits a photon out. That's the basic semiconductor physics thing which we use. But then the materials also reflect, scatter some bit of light, right? All this come as background photons. So here we studied a range of materials to understand which gives the smallest scattered photons out. So how do we reduce the background so that we can reduce the noise levels and get the actual single photons out of the device, right? So when we have nanoparticles, colloidal quantum dots, there are two problems with it. One is called the photo bleaching. So even if you put microwatt of power, and if you launch this power incident light for say few seconds, so in this case so within 25 seconds, so the emission is just dying out. So this is called photo bleaching. So the quantum dot just dies out, so it stops emitting any more photons, right? And what we see is uh, these nanoparticles, as the structure is shown here, right? So these nanoparticle has to be embedded in some metal or some dielectric layer, right? So we need to check the compatibility of the nanoparticle, the stability of the nanoparticle inside these materials. What we see is, like, even if we put say 2 to 3 nanometer of say titanium dioxide in this case, so the photoluminescence, the emission is dropping drastically from, this is bare quantum dots, and if you put a thin 1 nanometer thick TiO2, the photoluminescence drops by about 5 times, and a 3 nanometer layer completely kills all the emission. So you need to find right materials. We study different polymers, right? Polymers are a little better, right? So what this plot shows is the so-called Ormonde dip. How do we know when what we have is a single photon or not, right? One of the simplest measurements, or the only measurement technique by which we can say we have a single photon or not, is if you put a beam splitter, right, like a glass, some part is reflected, some part is transmitted. Now if you have a beam splitter which reflects 50% and transmits 50%, light is coming from this side, and if the photons are coming from this side, if you have one single photon, you put two detectors at the two ends in the reflection and the transmission geometries. So if you have a single photon, it can get either reflected or transmitted. So if you keep measuring what is the probability of finding photon in both the detectors at a given time, right, at time t equal to 0, we should get 0 probability of finding photon in both the detectors, right? If you have a single photon, it can only go to one of the two detectors. So that's what we plot here. What is the probability of finding photon in both the detectors at a given time? At time t equal to 0, that is the path length traveled by in this path and in this path is the same, so then we get a 0 probability ideally. Okay. So we show the single photon emission from these measurements, and we showed that basically hafnium oxide, which is deposited by atomic layer deposition, so that gives the best protection to these quantum dots. And the other problem which I didn't mention is, one is the photo bleaching and the other one is the blinking. So when you have a nanoparticle, it's a small in size, 2 to 10 nanometer kind of dimensions. When an electron is excited, it can go and get trapped on the defect states on the surface of the nanoparticle. So once it goes to the defect states have milliseconds kind of lifetimes compared to nanosecond of a excited electron in the conduction band. So for that short time, so the quantum dot doesn't emit anything. So there is a zero emission which is at these positions, right? Hafnium oxide also improves this, and up to 50 seconds, for example, we can get emission from these structures. Not just single quantum dots, there is something called nano diamonds which have nitrogen vacancies. So we do see emission from these nano diamonds as well in the single photon level from these structures, right? We proposed this noon state generation, which is interesting because if you have two quantum dots, the emission which is coming from one quantum dot is coupled to the second quantum dot through something known as a surface plasmon polariton. So on a metal surface, right, you have large number of free electrons. Under certain conditions, you can excite these electrons in such a way that you have more number of electrons at one place, that is more negative, and less number of electrons, which is relatively positive. So you have a negative positive kind of thing, and if you're coming at an angle of incidence, the photon is going to kick these electrons. So there is a momentum which is transferred, so which makes this wave to propagate along the interface. So the photons which are coming from this first nanoparticle excite the plasmon mode, surface mode at this metal interface, and then that plasmon is going to excite the second quantum dot. So these are now two quantum dots or nanoparticles which are mediated by this surface plasmon, and because of this coupling, they get some very unique features. Like for example, there are two photons generated, one photon each by these two quantum dots, but because of this coupling, both these photons will come either in detector one direction, that is plus theta direction, or in the minus theta direction. These are called noon states because there is nothing in between, right? So either in one detector or other detector, nothing in between. I mean, it's never like one photon here, one photon here kind of thing. Okay. So you also use these the so-called plasmonic structures for atom traps. For example, if you want to have uh, atom traps on a chip, so we design these structures so that you can have these silver and gold discs on top of which you have this potential trap potential profile. This is the near field profile in which an atom can be trapped, right? So we are currently working at NPL on this single photon detection using superconducting nanowires. The idea here is to first set up a single photon source, then have the single photon detector based on superconducting nanowires, and then you have the readout electronics. Okay. So how does the device work? So the device is a superconducting nanowire, which is a meander structure. When light falls on it, either it gets absorbed or generates electrons, which breaks the superconductor, which moves the superconductor from its superconducting phase to normal state, or local heating of the uh, radiation which is falling on it moves the device from superconducting state to normal state. Because of which, so there is this a sharp output pulse which is generated for even for a single photon which is falling on these structures. Right. So we made these structures and studied the superconducting properties, and now we are trying to do the detection with single photons. Right. So just to summarize, at NPL to meet the growing demands of the young aspiring population. So we support the Indian government towards its USD $5 trillion economy by providing the standards which are needed for the local economy for improving or enhancing our exports, and also to measure and test the quality of the imports which are getting into the country. Right. So this metrology is very important for the growing economy. So as National Metrology Institute, we set up and disseminate standards across the country through Quality Control of India and constituents like NABL, NABH and others. So NPL just completed 75 years in the service of nation. So we are looking to meet the challenges to help the government make our nation stronger, better and self-reliant. So we need to bring global solutions to solve local problems and address local problems. For example, how do we handle the waste, right? So landfills are major challenges. So only way to handle the waste is to recycle waste and make use of it, right? So we need to look at pollution control or mitigate the pollution effects, right? And we work on environmental aspects of these, right? So we look at the defense applications. We look at providing support. For example, right now we are setting up facilities for Rafale fighter testing facilities, right? So NPL is tuned into these efforts to support the society as well as the economy uh, by metrology activities. So, thank you. If you have any questions, I'd be very happy to take. So the time scale measurement, what the accuracy what we have for the country is 2.8 nanoseconds. Nanoseconds. Right. So we have bank of cesium clocks, and we have hydrogen measures which are more accurate. So we combine all these things, and yeah, we get it. Sorry, your voice is not audible.
About kilogram you mentioned.
Right.
So we bought 1 kg from, so that we remain dependent on the same measure. We have not made any changes so far.
Right. So far no, but from 2019, the world over, everybody accepted this new definition of the mass.
Okay.
So we are no longer in. I mean, everybody is trying to build.
Okay.
No country has this the so-called Kibble Balance. The idea here is it's a two-pan balance as usual. You put the unknown mass in one pan, and the second the pan is surrounded by an electromagnet.
Okay.
Right? We do two kinds of measurements. One is you apply a current and make sure that at what current level the pans are balanced because of the magnetic force.
Accordingly, that
right? Right. So the other one is we move the magnet up and down, right, with a constant velocity, known velocity, and try to balance, right? So then we take a ratio of these things to eliminate all the material, the length of the magnet and other parameters.
And the interesting thing is about the meter you mentioned. We measure from the North Pole to the equator. So how do you know equator position and North Pole position?
Precisely. Like, but this was the first definition which came out.
Okay.
Somewhere to begin with, but then they made these platinum iridium bars.
So we depend on that.
We depend on that, but even there, there are markings made, right? So there is always over a meter, like, so you can't get better than a micrometer precision, right? So now we use the interferometer based, right? Because when we are known wavelength, when we make it interfere, split it and then make interference, then you get the dark and bright fringes. The fringe separation is related to the wavelength, right? So the separation is very precisely known, and we get about 20 picometer resolution.
But when you have fringes, again you have to depend upon basic physics, no? That is the wavelength difference between the two fringes. So do you say, for example, red color you take or blue color you take? So the fringe difference you take theoretically or experimentally you depend on that?
Right. Good question. Physics, there is no escape from it. Right. You want to be good engineers, you need to be good physicists. Right. I joke that I got a second degree from Tokyo University just because I said I don't want to throw all the samples. Give me all the samples. I want to study why they're not working.
Okay.
Right. So being a physicist, I spent time to understand, and that's how I could get.
Thank you very much.
So there is no escape from physics. And to answer the technical point is the stability of the laser is extremely important, right? So there is this, and the BAPM, all the countries, they come and discuss. So there is technical committees which discuss what is right, what is wrong, what is better, right? So the standard which is used currently is an iodine stabilized helium neon laser.
Yes.
Right? Helium neon laser, we know it emits at 632.8 nanometer, but iodine stabilized emits at 633 nanometer with very narrow line width. Okay? So that's the standard. So now blue lasers are also coming up with high accuracy.
Thank you very much.
COVID-19 related apparatus and testing apparatus.
Right.
What is any
one thing which I mentioned is the UVC disinfection, right? So that's commercially available now. Anybody wants, like, it's good for hospitals, good for conference halls, right? It's installed in Parliament building, for example. So in the AC ducts, you can put them. This is CSA or Chandigarh has done it, right? So these are available from the CSAR. From NPL specific, yes, we have a UVC disinfection. So then we have PPE kit monitoring and testing. So we have the primary standards. There are 13 tests which are needed. For 8 of them, we already have the facilities at NPL. So, for example, one of the tests is the blood seepage, right? So we also have a primary standard now for the blood, right, or the blood equivalent. We cannot use blood for all the tests, so we need to have the blood equivalent. So there are for example, BIS has certain specifications, how much viscosity, what should be the pH, all these things are defined. So we have a primary standard based on those conditions, so where we can use that in place of the blood, right? So we have the PPE kit testing standards, and then we have scanners like the X-ray scanners for luggage and other things. We have the UV scanners, right? So yes, ma'am.
Thanks.
So I was asked to wait from starting the lecture because wanted the students to be here, right? So Professor Parthasarathi mentioned that compared to senior citizens, possibly students will gain more, right? And I was waiting for about 25 minutes for you people to turn up, but I don't see any questions from you people.
Obviously, each one of them will be asking questions.
Students, if you want to ask question in Tamil, you ask me. Ask him, then I will tell him, then you will answer. No problem, no, don't feel shy because he's a distinguished speaker. Distinguished speaker, உங்களுக்காக வெயிட் பண்ணிட்டு இருந்தாரு 20 நிமிஷம் ஸ்டூடெண்ட்ஸ் வரணும்னு. ஸோ ஸ்டூடெண்ட்ஸ் மாணவர்களே ஏதாவது கொஸ்டின் இருந்தால் கேளுங்க. He'll be very happy to say because that is a tax on you because he waited for you. Some students must ask questions.
Yes,
Chaube
please.
Saab, youngest person. Chaube Saab.
आप बैठ जाइए
Okay.
और डर लगता है आपसे First of all, I would like to congratulate you for describing what the NPL does. I never discussed these details with the NPL scholars, directors, so I had no idea what kind of work NPL does. I thought they are doing in the physics laboratory, but this is something beyond physics, although based on physics.
Yes.
It's very difficult for a common man to understand what is photon and how do you separate one unit of photon from the whole rays that is coming and things. So most of the students will not find, or majority of us, but that is a different one. You have given a good. My question is different. We are here discussing environment, energy, and health. How would you relate this NPL work in understanding and solution of this problem? We had thought that you will be speaking on this aspect,
Right.
but you have avoided perhaps, thinking that since we may not be able to know this, so first you give this information, they will elaborate. So it will be a second part of your things when you make us understand how these works of NPL enable us to understand the problem of health of people of India in relation to environment and energy. That will be good, and then these young men will be better equipped and they will be able to respond effectively.
Okay, thank you. It looks like I failed to convey the message. I have precisely given examples of energy where I given the example of photovoltaic primary standard. We make the solar cells, right? We make the facilities for LED for saving energy, right? So LED lamps are important, but what is the quality? What is the standard of the LED lamps which we get in the country, right? How do we test these things, right? How do we standardize these things, right? So we have the facilities in house. From the energy perspective, photovoltaics, we work on green hydrogen, for example the PEM, the carbon papers which I showed you for PEM cells, fuel cells, right? So these are all for the energy. I've given you examples for energy in terms of photovoltaics, PEM fuel cells, for LED calibration facilities for energy saving, and for environment I showed you calibration facilities for PM 2.5, PM5 and PM10 particle counters which are being made in India, as well as we export a lot of these things. And from environment perspective, I also showed you what NPL does by setting up these facilities across the world. For example, Maitri station in Antarctica, we still maintain and collect the data over decades, right? So the SODAR and other things are maintained at Antarctica. Our scientists go there and maintain these things, collect the data, service them and all these things. And we also have center at high altitude location in Palampur in Himachal Pradesh, where we have Rahman lidar, SODAR, all these facilities, because this is above the city or the local level, where the pollution is more, the industry above the industry's level. So that like this acts as a base level for the country, where the in the sub-Himalayan region, like, so we collect the high purity environmental background data to compare with what happens in the cities. So we maintain the environmental monitors in Delhi and across other places. So this is for the environment. And for health, I showed you examples of biomedical work which we are doing, biomedical equipment. For example, the standards in the country, we do not have standards for electrical safety, right? We heard horror stories of how babies got burnt in incubators, right? So we do not have standards. So we are setting up those things. So I showed you two examples of defibrillators. So these are used for heart patients, for example, giving the electric shock. Then I showed you one example of infusion pump, right? So these standards are there from health point of view, right? From COVID, I've given you example of PPE kit, UVC disinfection systems, both for rooms and hospitals, as well as for example, the luggage and other things, right? So I hope that.
You are satisfied with this report. So, Professor Narayan.
NPL is number one in maintaining standards, especially on pressure. You are number one and is well known internationally also. For the sake of students, I just like to ask on their behalf. It's a student question. See, now in the whole of India, every house has got a cylinder which has got 15 kilos of gas. Suppose with some innovation, if can be doubled, say 30 kilos in the same container, that will save a lot of energy and also environment, because transportation and the housewife, instead of utilizing the gas cylinder for 1 month, he will utilize for 2 months. So it saves a lot of things. So whether such type of, and what is the suppose for example, if you see the transportation of gas by the trucks which you are transporting, it has got a standard. That means you cannot put more than certain pressure. If you compare the European standard, is much more. So what does it mean? In India, the same truck, the same volume, take X. In Europe, it is taking 2X because their standards are different. So whether NPL is working in that direction to increase or allow these trucks to make more gas with a different way of material, so that it will be more India friendly. Just okay. Only on the pressure. There are several other, but pressure point of view I cannot.
Right. So I'll answer this question in two parts. One is safety is extremely important, right? I'll take the example of bullet train in Japan. It can run at 400 plus kilometer per hour, and it's operated. For example, TGV runs around those speeds. But in Japan, the bullet train is run at less than 300 kilometer per hour. Purely from safety point of view, it's not the capability. It is just the safety which is important, right? So the second aspect of this is there is a lot of new technologies coming up. For example, hydrogen, right, as a fuel. You need these tanks which are supposed to be much more safe, right? Now we have those. We see Nitin Gadkari ji going to parliament in a hydrogen fuel car, right? These are safe now. Toyota makes these cars hydrogen fuel cell cars, right? So the containers are safer now, right? So it's just like adopting it to our requirements. So the technology is there, right? And to directly answer your question, does NPL work on this? No, we do not work on the cylinder materials, right? But this technology exists.
Right? Thank you.
So, many of us were not knowing that the indelible ink has been tested and made by NPL. It's the hallmark of democracy that has been created to identify that there must not be bogus voting. So identified it. It's really remarkable. Now my question starts from here. That now the democracy, the other dimension has shifted to EVM, and lots of questions are there on EVM. Is there any work that NPL is looking into it to shape that democracy like in indelible ink?
No, but coming from TAFR, so NPL has no role in the EVMs, right? But coming from TAFR, there is a Bombay connection. So IIT Bombay professors are involved in the security and safety of the EVMs, and they vouch for the EVMs. They are tamper-proof. Right?
Any other questions?
Good morning, sir. So you spoke. I'm Ramya Shri. I'm doing my master's in physics at Crescent Institute. You talked about quantum dots, sir. Sir, is it possible to use quantum dots as the scattering medium to provide optical feedback in Raman random lasers, sir?
Absolutely. So for example, these nanoparticles can be used for as a random laser, right? So you excite, but then these nanoparticles act like scatterers which are randomly distributed, right? So there is something known as Anderson localization, which is basically light gets scattered within the medium and doesn't come out. It's like a cavity in which we're localizing the field. Because of this random scattering, so you get very sharp peaks in the emission lines. So those can be used as references, right?
Thank you, sir.
Yes, please. There's one more.
One more question. Yeah, sure.
So, from the management point of view, regarding the NPL operations, is it a monopoly or your organization is having any competitors in India as well as in international level? We just want to know how the operation is exactly existing, and this is the question from the student side. It came to me. That's
Okay.
why I'm asking you. Thank you so much, sir.
So, as I mentioned, from the standards perspective, it's a responsibility. It's not a monopoly, right? NPL is mandated by the parliament, right? All over the world, one institute in a country is designated as the Metrology Institute, and it's our primary responsibility to make sure that we maintain the primary standards in the institute, right? And we also set up, and then we also have the duty to disseminate this, right? So NABL, NABH, all these things, we cooperate, collaborate with them, and independently we talk to the industry. For example, MSMEs. I mean, I'm a scientist working in the lab, and in last June I moved to NPL, and I'm also learning the management tricks and what needs to be done. So that way there is no monopoly, but we want to work together with the industry. For example, I go meet them, ask them what standards do they need, right? So for example, Tamil Nadu has certain industry. For example, CLRA says like we need for the leather industry, we need these kind of standards. So we are trying to set up something in locally here so that they don't have to come all the way to Delhi. Right? So it's not, it's mutually handshake which is needed.
Actually, I thank you, but I can partly join him in answering you. There's something called ISI standards. Let it be pressure cooker, gasket, anything ISI. That ISI gets certification only from NPR. Okay, if you can also make, but it will be sold in more markets. But people will look at ISI standards. ISI standards are certified only when NPL provides certification. They have unique national role. Sir, thank you. A special thanks by our registrar because your lecture is so special, and very rarely we get a distinguished speaker like you to the campus. I would like to welcome the registrar. Please come. He would provide the word of thanks for you, especially.
First, respect.
No. After word of thanks. After word of thanks, please. Please. Because your special lecture, otherwise he didn't do any word of thanks for anybody.
Good morning to all. On behalf of B.S. Abdur Rahman, Crescent Institute of Science and Technology, I would like to express our sincere thanks to Professor Vanu Gopal, Director, National Physical Laboratory. The presentation and the explanation by an eminent scientist, Professor Vanu Gopal, was really revealing. They are the standard keepers, of the country. They are a government organization. It's one of the earliest laboratories started in India. You know that when we got independence, as people say, we had to import even needle from abroad. So what our government did, they had to start everything from the scratch, which includes maintenance of standard, right? We say, I want something 1 meter. How do you know it is 1 meter? Imagine the clothes sold in India. It is, millions and millions of meters. If 1 millimeter is reduced in that, what is the loss for the society? Okay. Then, sir has also explained a lot of physical phenomena. It's because the metrology has to be many times better than the actual measurement. For example, you know that vernier caliper. The vernier caliper is 100 times, more accurate than what you are measuring. For example, this is the diameter. This is the diameter. You have to measure it at not in millimeter. This may be 10 mm. 10 mm, 10.01, 02 like that. You have to measure. Then if it is much more accurate, you have to measure at a three-digit accuracy. Like that it goes to micrometers. Then when the technology improves, you go to nanometers. Today, they are going to produce chips with a 2 nanometers. It is very, very, very small one. You can produce 2 nanometers, but how do you know it is 2 nanometers? Right? You go to the shop, they say 1 kilo of this. Are you sure it is 1 kilo? So there should be an ultimate measurement, which the measurement itself should not change. That is a great work done by our National Physical Laboratory. It's a fantastic organization. It's one of the best endowed laboratories in India. It is if somebody says they have been to NPL, it is a prestigious thing. Okay, going and then coming to NPL itself is a prestigious thing. And our professor has come all the way from Delhi despite of his busy schedule and his presence in our B.S. Abdur Crescent and Crescent Institute of Science and Technology is a very cherishable moment for us. It's a great honor for us. We thank you once again, sir. Thank you very much.
Thank you, Registrar sir. I must tell you, NPL is a institutional membership of Indian Social Science Academy. I would be very happy if your institution also become one of the institution member of.
We'll become members.
Okay. Yeah, fine.
Thank you so much, sir. As a token of our appreciation and respect, we would like to honor the eminent speaker with a shawl and a memento. I request our esteemed registrar, Dr. A. Azad, to honor Professor Vanu Gopal. Thank you, sir.
Good morning. I would like to know by any chance I missed the other speakers. If they are here, please raise your hand. Professor Ashok Rao, I didn't see him since morning. That's why I took a little leisurely time of asking question and answers. Okay, he's not here. Speaker 2, Balachandra, Professor Balachandra. I don't see any rising hands. Okay, I see rising suns, not rising hand. That's it. The third is no. So I would like to hand over to General Secretary. Thank you so much for your patience. Special thanks to all the students. Next time when such a seminar there, you please be on time. Please don't ask speaker to wait for your arrival. See, he waited. Fortunately, 2-3 students asked questions, but students should not feel fear. They should ask questions. Nothing wrong because all of us, we don't know everything. So please shed your shyness and ask questions. Okay, I'll hand over to General.
Thank you. We propose vote of thanks to our chair and the speakers and all the participants to be here for this morning session. You have made a good beginning. Now we are breaking for tea, and after that we'll be reassembled for the second plenary, for which a speaker has already arrived. So be it quick so that we'll come back and start again. Thank you so much.
a remarkable service to humanity. Brigadier Pogula Ganesham, born in village Boompalli of Telangana, is an engineering graduate from Osmania University and MBA from Delhi University. A specialist in armored fighting vehicles, served the Indian Army with distinction for over 35 years. He was instrumental in developing a multi-role weapon platform Bindi for the Army, which was displayed in the Republic Day Parade 2004. He also obtained the patent for this vehicle, which is the first patent of the Indian Army. For his distinguished services, Brigadier Ganesham was awarded Vishisht Seva Medal by the President of India on the occasion of Republic Day 2005. Post-retirement from the army, he formed a voluntary group Palle Srujana with like-minded friends to promote knowledge-based activity in unified Andhra Pradesh in 2005. They publish a bi-monthly Palle Srujana in Telugu for dissemination of grassroots creativity and traditional knowledge since 2006. Palle Srujana conducts Chinna Shodha Yatra every quarter in various parts, both the Telugu states, to walk in the remote areas to understand and capture the grassroots knowledge and the creativity of villagers. These yatris are the future social leaders and change makers. In the last 15 years, he addressed over 90,000 students in both Telugu states and walked over 4,000 kilometers across the country in remote areas, visiting over 1,200 villages. He built a voluntary network of 3,000 in Telugu states, and in the last 15 years, they identified over 300 innovators and documented more than 2,000 traditional knowledge practices. Palle Srujana facilitated many grassroots innovators to be recognized by national, international, governments, and private organizations. Palle Srujana seeks problems from the society and provides solutions utilizing the creativity of grassroots innovators. In the past 5 years, over 20 problems have been solved by providing suitable products. Brigadier Ganesham conceived a new model, grassroots entrepreneurship, for disseminating the grassroots innovations, which helps grassroots innovators in providing market and finance for manufacture. His major initiatives include Gram Swayam Samruddhi, Rural Internship, Gyan Shodh, and capturing creativity of school children, Ignite the Minds. His mission is to highlight the significance of grassroots creativity for an equitable growth of the nation to the students, industry, scientific community, society in general, and the government. We are indeed honored to have Brigadier Ganesham amidst us in this 5-day Indian Social Science Congress.
Now, since Professor K. Murugan is with us, may I request him to join this panel? Please join us.
Well, good morning to you all. I think you have just now heard a lot of things for the first speaker, and actually the very important word is grassroots. And I'm sure this will be very useful lecture, and you are ready to listen. But then I am thankful to the organizer. You put people to in the front rows, but I find still some inertia. People are moving just 2-3 rows, and still some rows are vacant. I don't understand. If somebody can tell me the reason, if there is some benefit with sitting in the last row, you will be awarded really. You have to come to the first row, then only you can read the slides. Otherwise, you can't read the slides, so you will be sleeping simply. Right? Anyway, it's very good lecture. You please come forward, and that's what my request is there. I can't force you, in fact. So I would like to invite Brigadier Ganeshan for the first lecture. Already, sir, we have heard about you, and now you will hear your lecture. I'm sure it will be very useful for all of us. Thank you so much. So, right. Well, that is, he retired, so there is no problem. You can sit down there. So that,
Very good morning, and thank you very much, our Indian Social Science Academy, and the BS Abdur Rahman Institute of Science and Technology for allowing me to stand here and face you. Hopefully, I'll make people at the back smile and do not allow them to sleep. It's a challenge to me. Let me try. Okay. Please. Next. So, there's inequality. The inequality everywhere. Especially when I walk through the villages, we go to villages with zeroing ourselves. So we see a situation in real. We find inequality there everywhere, in every aspect. Inequality is not in terms of money or opportunities. Inequality in treating them as humans. You don't respect a villager as you respect your own self or your educated man. Tangibles, intangibles, everywhere there is inequality in this country. And we signed a constitution for making it equal. The major organs of governance or development are, most important one is science and technology. And it involves energy, health, environment. I think everything is an offshoot of science and technology. But does science and technology and the governance of science and technology or the institutes of technology, have they done well in the past? Are they in the right direction? Are they going to reduce this inequality which we see every day, everywhere? Or it is fueling it to become more, bigger and wider? That's what I would like to express you from the grassroots point of view, from the villagers' point of view, mass point of view. If you heard it, fine. If you've not heard it, I'm sure you'll find it interesting because the perspective I have learned and I found it amazingly exciting. So the entire social system, ecosystem has got public innovations and which involves various scientific labs and other things which are funded by the government. And in my understanding, they haven't done well. They have left out majority of the people. They left out majority ambitions of the majority of the people. Not ambitions, aspirations, and then unmet needs. Unmet needs have not been addressed by public innovation, whereas they are meant for that. And the second one is the private innovations, where people in the private, they work for business. Therefore, they look for those who can pay for their products. So therefore, even the second category has not addressed our friends in the masses. We have another category, school innovations. I put it in the red because we all forgot about it. 26 crore children, you all came from schools. I was also in a school some time back. We think that school children are not creative. They'll start thinking only when they become MSc or engineering or doctor. I think silly opinion we had. We lost all the creativity of children right from the beginning. Even now, not much is being done. They stay in the midst of problems across the geography of the nation. Every problem, every unmet need around them is felt by them, seen by them. Who else can be more competent to speak about the unmet need? And when they see that problem day in and day out, they can't bear the pain. They use their creativity and find some innovation, some idea, but they can't make it. It's our job to capture those ideas. And that ideas, because they're directly addressing the pain around them, imagine what will happen to the nation if we capture 10,000 ideas every year coming from the children, and that many pains you're reducing it by commodifying it or making devices out of it. I think we need to take care of it. The last is grassroots innovations. When all these categories ecosystem is not working, the people are angry, they get frustrated, and they become innovators. So we call them grassroots innovators. And this is what I like to give you some examples of creativity at grassroots. Yeah. So we believe that people in the villages are not sinks, they are sources. With that conviction, we walk into the villages and they never disappointed us. Next. So what do? Their innovations are mostly frugal. Because he decides, one day he decides with nothing at his disposal to do something, solve his problem, reduce his pain or pain of neighbor. It is frugal because what is local resources, local technologies, what he can afford only he does it. Therefore, it's frugal. And of course, environmental friendly because villagers do not destroy environment. We tell them to do it. If possible, villagers always try to live with it, not destroy it. You see, all these things I have written after analyzing the innovations. So you see them now, you don't explain, but when you see the innovations, perhaps you agree with all of them. Especially on the theme of the seminar, energy, health and environment, these innovations I found them perfect candidates. And that's what we are going to deduce at the end of this presentation. Next. Next. Not moving? Okay. Yeah. Okay. So we represent Palle Sujana. Palle is village. Sujana is creativity. It is in Telugu. And we believe in that. We have no questions about it. Villages have creativity, and we went on. What we do, we go to the villages because knowledge has no legs. We have legs, so we have to go to the knowledge. When you go to the knowledge, we identify it. We give them visibility. We give them voice. We give them velocity. We all done by volunteers, and that's the way the knowledge in the villages, creativity, and the traditional knowledge brought into the formal system, so that system utilizes better for the development. You call it, Prime Minister says, local for vocal, something like that. Next. Okay, they do with knowing, feeling, doing. Move on, and we'll understand more. See, the walker was given earlier. Walker was there in the market with 4 fixed legs. Just watch the video, you'll see the difference. If the small staircase comes, the man needs help. He puts the walker aside. Okay, it is not, it's useless. Tell me a place where not even one step is not there. Then why have you given the walker which is useless to him? He needs to depend on him, he or she. Now here a small idea that the front legs can be manipulated up and down, extended up or down, and that's it. So this comes in our understanding is knowing, feeling, and doing. If you jump from knowing to doing without understanding the feeling of the problem, you don't live in the problems, this kind of a designs may occur. And we are given only 1 0, 4 legs walker. After that, there is no scientific institution, no engineering colleges have thought of giving 2 0. They are very happy to give 1 and forget about it, as if no development can be done. Yeah. Next, please. Move on. A harvester. Just a second. Harvester, there is a cut. It looks like the one on the left side, your left, 8 inches paddy. Then all the pieces of grass is thrown into the field. About 5 quintals grains fall in the field, and the farmer is denied grass. Farmer gets 2 products, grains and grass. But harvester ensures, sorry to use this word, but ensures that he doesn't get grass. What is this mechanization? When you deny a product. Move on. Click the video on this. There is one Surendra Prasad, a grassroots innovator near Lucknow. He was unhappy. Just click that. No, go back. Go to the full screen. Click on the right. Click on that, please. Yeah, that's it. There you are. So he modified the existing combined harvester, spending 2-3 lakhs rupees. Never went to school, but he addressed his pain and the pain of others. Because system failed to do this. What it does, I won't explain, you watch. It gives grass to the farmer, brings from the field and gives total grass to the farmer on a platter. It doesn't throw in the store or leaf stubs and also grains. Now this is what a harvester should be. There's no loss to the farmer, least loss of. And what is the loss of grains? Cutting is not done in the field, it's done in the harvester. So loss of grains is about 5 to 10 kgs per acre. Maybe a couple of things, but from quintals to kgs. Now this is what it can be. It can come, but it has not come till today because a farmer has made it, but he's not an entrepreneur. He has got a patent. He has got an award from President of India in 2015. But this harvester modification is not done at all. or it's rich people. When I show this to farmers in the villages, they jump, sir, kab milega? Okay, you understand the difference? How much it's good for any kind of a things, like you talk about every innovation I show it to my dear friends, please see it through the theme of this Congress, energy, health, environment. I don't want to talk on everything, but there is a benefit for all these three in every innovation they make it. Here, people are burning grass. Elders will tell you that farmers never burnt fields. There's no need. The need came because of mechanization. But this is not what Arnab Goswami speaks on the TV. Nobody talks about mechanization. This burning is coming because of the harvester. But they got one more baler to create they created a problem and solved the problem. Therefore, more energy consumption, more carbon, more everything. So this is what science does. Then I think they have to look into it seriously. Why it is happening? Yeah, next please. Now, what we found from this 16 years of my journey with the people is that if you have a knowledge of the problems, right knowledge as a feeling, then you use your creativity to solve some of them. And when you solve some of the problems with creativity, innovation comes. Innovation is something which you can use. It's an application innovation. Innovation is not a theory, not a proof of concept. When somebody uses it, their pains reduce, happiness enhances that much. Ultimately, we all live for happiness. And if society is happy, countries are happy, I think globe will be happier, peaceful. Yeah. So with the three verticals of society, today the themes of the Congress, environment, energy and health. Now if they're going independently, growing very well, but they're not synchronizing the growth or adverse or positive effects of their initiatives and other two, there's going to be disaster, and which is what we are in today. Now, these grassroots innovations, creativity at the grassroots, not understanding these big words, they have by default incorporated least adverse effects in other two. And that's what synchronization is done. Science has to do it, but grassroots innovators do it otherwise. Maybe there's something to learn from them. Next. Hand pump design was given when I was child. I saw this hand pump. Is there a change after that? Anybody has seen any better hand pump than this? Anyone? So 72 years I am now. शोभे जी मेरे से बड़े वो भी नहीं देखे होंगे. इसका कोई 20 आया नहीं है. क्या नहीं हो सकता है क्या? But we are insensitive to our people, and we don't worry if they are. We are biased to our own people, but we're not worried about it. We don't think about it. We don't care about it. Next, what happened? Somebody thought of it. Some parents, they saw their child waited in the school lunchtime, and she did not get her turn, and when she went to the class, teacher punished her. She cried. The parents asked why. So when she explained humiliation, parents felt that some Vedana of the child, they internalized it. They said, let us do something about it. When pain is bothering you, don't keep quiet. And they went to the principal, asked, can I do something? The good principal said, okay. And that's where we met 1:1 to 1:7, my dear children. If you like this innovation, please clap for those parents, please. For youngsters, if you do something good, please appreciate and clap. And for clapping, you should be a leader, not a follower. Otherwise, badness will take over you. Don't worry for someone to clap for it, and not for me, for the innovations. Now, this is a 1:7, imagine. It is water saving. No wastage of thing. For 1:7, imagine 1:1. And the least, anybody can make it. You don't need drawings, you need support from government or a bank or anything. And that's what really is an innovation which reduces pain and enhances happiness. Next, please. Earlier villages have these bullock carts to carry people, material, all kinds of material. But this is vanishing slowly for various reasons. But what is the transporter system they have in the village today? Zilch. Auto or tractor or trolley. And can't be afforded. People can't afford it. Did we give a unmet need of transporter for village where they need to carry stores, agricultural machinery, or so many things in the village? Nothing is that. Next. Now this boy Nayak has made a small trolley, 6 by 5 by 3, four-wheeler, and he ensured that it can be driven by all the vehicles in the village, by moped, by motorcycle, by tractor. Next. And it can be driven by Activa, and anything can be taken on that. And advantage is that the people can, a young man having a motorcycle can have this as a employment also, but providing a happiness to the people. This is unmet need of the village. Simple. You don't need high tech for that. You need sensitivity, a little bit of samvedana for the masses. Someone made electric vehicle 3 years back. Electric vehicle of 1 lakh rupees only made in the village. It can also carry as a 40 kilometers endurance in a day, 4 hours charging. That also meets unmet need using less carbon. Yes. We have seen people leaving toddy, people have coconuts. Government gives lots of policies, promotions of local toddy. But what is designed by our ancestors to one for the one ring for the waist and one ring for the feet and 5 knives they carry. Same design of tradition is going on with them, but you not add anything. Okay, if you don't want to drink toddy, it's okay, but you can always make his life better. So to climb up, next please. Climb up, Venkat from Coimbatore has added a beautiful device. It says sit down and go. Can you click on the right one? It's a video. Yeah. So he moves up so beautifully, safely, and walks there with 2 hands on the top, can carry something to the frame, and so successfully he made it. And he is not even a graduate, Venkat. Now there's no power in this. Just a normal tube, and it can be, depending on thickness of the tree, you can adjust the bars. Everything. Nature is not standardized. Nature is customized. He made it for a customized utilization. Imagine, we can only make standard utilization. If anything customized, we cannot make one piece. But he made one piece for different trees, which are so different in their depth. Yeah, next. People have been working in the shade, the open, thousands of years perhaps, and crores of people work in the open. We don't bother about them. And we can't stay 10 minutes in the sun, but please shade me aajao. We can't stay. Anybody will request them. But they work in the sun whole day, and they don't work, my dear children, we don't get food, by the way. But you've not thought of their comfort. When they go home in the evening, they don't even smile and be happy. They don't eat dinner with a laughter. Maybe we can at least give that. One boy, Shanmukha Rao, has made a shade, simple one, 5 feet by 10 feet, 2 poles, two wheels, erection time 15 minutes, and then put it there, work under this and move on. You can go in the wet crops and dry crops. You can modify it. And he says it is to be manufactured at every village. Our transaction costs are more than the actual cost. But look at the value. It's not a product. It's not a process, but it gives a comfort, and that happiness is priceless for the nation. $5 trillion is good enough, but 20 crore people having this drudgery and the strain, maybe $5 trillion is not worth it. Think about it. Next. Yeah, we have cotton, amazing number of hectares of cotton, but there's no cotton harvester. People have tried, but not come at all. And all the kind of fertilizers we put on that, and ladies wearing gent shirts, full shirts, go and start packing them because all the acids and the chemicals fall on them. But till today, we don't have a cotton harvester. Why not? And you know how many lakhs of hectares cotton is being grown in the country. We can try. Yeah. Dishwasher has become almost a must for middle class and low class because husband and wife both work, and our greasy cooking remains same. It did not change. And you have to cleaning is a problem. And husband does, wife does, don't know. They both postpone it in the evening. When they come, there's one more fight again. And it's not easy. This boy, Shanmukha Rao, he made a small device, 2 feet by 2 feet, with 2 sensors, and you take the dish. It automatically starts giving the soap water and the normal water. You keep on rubbing, don't with hand, but rotate the dish in front of the brush put there. You can change the brushes, bottle brush, any brush can be used. Then after that, take it to the next step. Put it on, please. I forgot. Video last person. So take it to the next stop where there is a fresh water comes up and then automatically sensor gives a play. Now we are reducing the pain. We're not removing the pain completely, but it's much better than doing with hand. Avuna, will you agree? Is it better or is it as bad? Yeah, some happiness, at least they think that they have been taken care of, and of course somebody can improve it. And the cost is 5,000 stainless steel piece. Affordability is very important, affordability. And if you can't give it an affordability for whom you have made, then what's the point making innovation? Yeah. Okay, you got an idea. One can improve on this design. Yeah, next. As the cables, in the waste sector, we have waste creators, waste collectors, waste segregators, waste recyclers, and waste destroyers. So much change is there. We hardly know about it. Used cables is the biggest waste, which is creating so much of pollution. In only Vijayawada, 1 year, we took out actually 50,000 tons of used cables were thrown. 50,000 tons, one Vijayawada is a small town. This is the way they burn. So the plastic goes away and inside material is taken out, they sell the material. It is a big menace. You all know what problems it creates to the earth, environment and everything. But it's happening, my dear friends. It's an unorganized sector. Next, one boy, Jalil, he found a method, cold method for this. Next. And click on the right one. He made a small device where he has got so many slots for different diameters. He puts that and it gives the slices. It opens it and takes out like this. Just slicing is done in this machine, cold machine, and takes out the plastic. Plastic is separated, metal is separated, metal quality is good, plastic quality, both they can sell and making money, cold process. In one stroke, this gentleman has added so much to the environment, avoid environment damage recurringly. Again, request, if you like it, you may clap. And such things have to be made every village, every town, but don't make it mass manufacture. Make it a manufacture by masses. Yes. Next. I'm sure most of you have seen this living bridge in Meghalaya. Somebody was there from Meghalaya. Professor, yeah. I had the opportunity to go there and stand on it for half a day. It's a beautiful piece. Now it's made with a community innovation. Why have they made it? Because there is a need. They have to cross the small stream, without which they cannot go to their fields. And somebody out of it thought about and used the nature, put a plant and nurtured it for 30, 40 years. Maybe 1 generation and a half has worked on that. It's a community innovation. And it doesn't get old. It gets older, it becomes stronger. Unlike our bridges where it becomes older, it becomes weaker. Now that's a kind of innovation. Why not? Why not we use, are we learning something from this? And why not? Nature provides so many things. Yeah. Today, the farm sector has been given only big tractors, big harvesters, because that's what they got from abroad and TOT and made it. There is no tractor made in this country, correct me, my statement, country made for Indian conditions, for Indian small and marginal farmers, no tractor. So this boy Sezachari made a 600. You click both of them, one after other. Both will work. Both work. Okay, that also. So 6.5 horsepower he put on a small mini tractor, and he and his wife, a trailer of course 800 kg it carries. He and his wife cultivated 5 acres of cotton without calling a single labor. Whenever the labor required, they made attachment for the tractor or the trolley. 5 acres of cotton. Now what does it prove? That you don't need big machines. You don't find a 25-pounder gun on a bird. So appropriateness is not the factor in design for us. It's very important for health, environment and energy everywhere. And if this can work for 8 to 10 acres, why 25 horsepower, why 65 horsepower tractors are required for them, and why we subsidy? This has to be thought over. If you give a product, people will lap it up. Now he sold more than 200 pieces. This boy in a village, he sells it 1 lakh rupees. Farmers buy, no subsidy. If there is an unmet need, you give it, they don't mind paying it because they know it is really meets their needs. When we don't do it, we need all kinds of subsidies and this and that and things are required. Next. Look at the way it carries. Now, head loads is going on all over. Even now, head loads are there. What have we done for head loads? I'm sure some of you must have carried, but I carried enough head load. It's not easy at all. I carried water, I carried grains, a lot of things the village we all carried. It's not easy. It's painful, my dear friends. You don't even know the pain, at least understand the pain, how difficult it is. And they have to every day up and down. So many kgs of kilometers, liters, kilometers they carry. But nothing is being done. Some idea should come up. Next. Now here in the Pani Hari, there's a girl from Rajasthan, she made one. She made a ring and 2 legs and the U shape on the shoulder. This right one, both of them are pictures. Okay. So she puts the ring, puts the whatever the vessel there, then slowly puts this on the shoulder, he fixes it and adjusts the height. And that's it. She walks without even holding it so beautifully. Good. It should be loudly. It should be made, tailor-made for each height, head to shoulder. It's a tool, personal tool, and so easy to make it. There's nothing very great technology. Anybody can make it. Any villager can make it. On the right side, this boy Lohar from Maharashtra, he made a plastic rectangle with the way you see it, and the top you put a plate. And the whole rectangle is tied to the plastic pipes are tied to the waist and shoulders. The plate on the top is 1 inch higher on the head. It doesn't touch the head. So when you put 80 kilograms load, it goes onto the body. And body's area is big. It is like a column. There's a water, there's air, there's blood, there's a flesh, there's bones, there's a fat. Like a column. So automatically the area of loading is increasing, so you don't feel the load. But on the head it was not so. The neck it was not so. So what did this boy do? He only changed one thing. Load center. 5,000 years we have been struggling. This boy could do changing the load center without cutting the anatomy, doing it. The load center changed. If you are impressed, you can clap again. I request you. For me, it's amazing innovation. Because today you can carry 80 kgs in one go. And whoever got a bigger body, they can do more. A short body maybe less. And what investment? Zilch. And it can be made anywhere in the village. And you can do better than this. No energy, but productivity is recurringly higher. There's a comfort, there's happiness, there's health for the people. I don't know, talk to a lady who carried water throughout her life at the age of 50. Just ask her what is the pain she's saying. Please go and ask somebody. Make a trip to village and ask. 50 years after carrying water and everything on the head, what is her feeling or what is his feeling? They will understand in which utopia you are living. Next, please. Mirch powder is almost everywhere used. But the process of mirch powder, the domestical in the villages, is that there is a click the right one. There is a pounder, it is given by spice board, but after pounding they have to sieve it. Sieving has to be done manually, like you on the left side. So this girl was working in Gadwal village of Telangana. Her husband did not like the sieving every day, 50 kg to 80 kg, that is a livelihood. So what he made? He made a small linkage for the sieving and the behind. Just for same machine, he made a linkage which sieves. I hope he is a man. Nazir Ahmed is a dumb man. He got Rashtrapati Award. We connected him. Why not? So he made the small one, we automatically sieves and the whole thing is come. What a beautiful innovation. Energy, health. Otherwise, kind of health, when you sieve, have you ever tried? Please try it out. You keep sneezing for next 1 week. If you sneeze your chili powder. Yeah, next. Pole climbing. We have people climb poles for telephones, for cables, for CCTVs, for electrical. No way. And all cement poles is so tough to go. We're not thought of that. And there's an unorganized sector. If they fall down, the family collapses. There's no insurance, nothing. But we're not worried about it. We see every day. This boy, click on the last one. The boy Tirupati Rao has made a simple one rod, put in the Z shape, put a slipper on that, tightened with screws, and it goes up. भाई आपको तालियां बहुत धीमी चली जा रहा है, कुछ ऐसे होना चाहिए कि तिरुपति राव को सुने आना चाहिए. He has got award, National President of India Award, Best Entrepreneur Award. He has got award, the Asian countries first prize for this silly innovation. Asian countries, they could recognize, we can't recognize. And now every state government is buying from them. He has got a design patent. But he said, what the idea patent? He comes to me one day after 1 year of his innovation. He says, sir, how can this reach all people? My lifetime is not sufficient. He's only 28. Then what do you like to do? I asked him. He says, sir, I want to put in the YouTube and everywhere people make it. He put the entire design on the YouTubes everywhere and people are making all over the country. Now look at the person's pain. He says, pain is there, pain for everybody should be taken off, not only for me. And still, despite all that, he sold more than 1 crore worth in 1.5 years. That's why he got Entrepreneurship Award also. Yeah, next. Tamil Nadu board is ordering 10,000 pieces. We just got 3,000 order for him. Electricity board. Yeah. Now this urea, I think the fertilizers came somewhere when I was young, when I was in college, 67, 68, I think so. In my village, it came in 73. The only way fertilizer is throwing like this, or bend and put in the at the plant. This is the only way. We have been giving fertilizer subsidy, everything, but have improved this method of dispensing fertilizers? Have you ever thought of it? Isn't it a waste? The way they do it is the most appropriate way. If you don't bend, you throw it like that. So it doesn't go where it's supposed to go, it goes where it doesn't want to go, should not go. Who is a loser? As a nation, every one of us is a loser. But not even a single science or engineering technology has given any kind of solution for easy dispensation or effective dispensation of dispensing of fertilizers. Next. And people did not keep quiet. One boy made this. Amazing. When I went to village, I asked, कुछ बनाया आपने? ये 20 मिनट के बाद एक बंदा आता है पीछे यार, ये लेके आता है. You see the design. He puts the bottle, closes it with a wood, puts a pipe. Now he can locate where to put the thing. He can control the quantity by stick. What is required in dispensation? Location and controlling of quantity. Both is there in this silly innovation, innocent innovation. And it saves 30. Zor se maro. Class, why you are silently? Have the courage. Be a leader in good things. Now, he made this what cost, but he saves 35% of urea, my dear friends. 35%. We are paying our tax for that. Free, 70,000 crores for fertilizer subsidy. But dispensation waste, environment affected. I hope you got the idea. Did you? Anybody understood or understood? Silence means what? Understood? Okay. Next. Click that. Mahesh was work from home during the COVID. He saw his father dispensing urea. Then he made a different method. Just see. Use a backpack for urea. And he locates and one press some quantity. You want more, he presses twice or thrice, depending on the requirement of the plant. So beautiful. And it can be made in the village. There's nothing you need from outside. Actually, it should be made, all this, they come for the votes. Don't give them money. Give these things to each farmer. We must make compulsory election commission that all candidates, when they go to villages, they must give all these tools, other things to people so they can use them and vote, of course. Okay, next. Now, spraying is another activity. All kinds of spraying we do in dry and wet. And you don't know how much is getting wasted, how much getting into the farmer's body, and how much painful it is, how much energy is consumed. We don't care about it. We have no idea. But it's one of the most periodic activity, intense activity in the farming, especially after the chemicals have come in. Now you use a cycle, no energy. Just push it. The rear wheel gives you the drive. Don't like cycles? Nobody clapping? Look at the sprays as good. And look at energy, health, environment. The man is walking in the front, spray is in the rear. Tell me, his health will be good or not? All the space we given is in the front. You are walking into the spray. What kind of seniors are the society? We put our village people in the jeopardy. अपने बेटे को नहीं लगाते तो उसको क्यों लगाते? वो भी तो अपना भाई बेटा है. Yeah, next. They are spraying by solar. But all these sprayings are only 3 feet, 4 feet, not more than that. We have not leveraged the farmer to become highly productive. We don't even think about it. This boy, what he did, Maulali from Andhra Pradesh, 300 feet spray. Just 300 feet spray. Can you imagine from 3 feet to 300 feet? And this is where people should get Nobel Prize. And what is used? Normal things. Instead of having a half horse per pump, you put a 3 horse per pump motor. That's it. It takes it for 300 feet. Look at the productivity of a very simple design can be made in the villages. Absolutely decentralized manufacture. They don't need any technology. But productivity of the nation goes up. Input cost of the farmer comes down and health improves. Environmental effects, of course, there. Yeah. Next is seeding. All kinds of, you eat मूंगफली खाते हो, वो सब खाते हो आप लोग, but seeding कैसे करते हैं? Bend होकर करना पड़ता है. Look at the left and those pictures. Now this boy made innovation where there's a clip at the bottom, you put a seed and just lift it, the seed drops, automatically closes. And without bending, one lady can do 1 acre. Whereas 10 ladies whole day, they cannot do 1 acre. So don't our ladies need some happiness? We want to eat all the things, but we have to give happiness also. That comes by very simple. This is cost is zero because recycled material is used it. Next, it has got a best prize in India International Festival of Science in Calcutta. Next, now weeding in the paddy is amazingly tough, and it has to be done periodically. And for farmers, a nightmare. Use that. See, look at the weed on the left one. So much weed. Weed is like paddy there, and manually you have to pull it. If it is bigger, they have to do more effort is required. And the delay comes up because of labor is not available. Right side, somebody made a herbicide, herbal weedicide by putting that. Look at this, no weed at all. This year we are given 5,000 acres this weedicide. In paddy, if there is no weed, farmer is a dream for him. And herbicide has come. So far we only got a chemical weedicide which has banned, but this man has made it. Look at the beautiful paddy field. It is giving 25% extra productivity. What is it doing is, it is destroying the seeds of the weeds. When it destroys seeds of the weed, doesn't destroy your transplantation, then that nutrition available also goes to your plant. So thereby the growth 20% coming. Simple. I am not a scientist. I have understood from the innovator. So such innovations are available. Why aren't we doing it? Imagine when we went to the system, we faced all kinds of questions. 50 lakhs is required to test this, they said. Where is the farmer has 50 lakhs? So it's a healthy system. We started selling it directly. This last season was 5,000 acres. This year we're hoping for 1 lakh acres. But all legally, of course, without license. Yeah. Next. Yeah, in the villages, there's a loading and unloading takes place, and today we have a lot of machinery, a lot of agriculture equipment, a lot of construction equipment coming up, but we have no crane. There's no crane in 6.5 lakh villages. Manually karte hain, I say, loading and unloading. Unmet need, we not even thought of it. How much time it takes to give a crane to them? Next. So one boy made a crane, made a crane as an attachment to the tractor, which is available in almost every village. And the boom, the green portion boom is the only modification he did as a crane. It lifts 800 kgs for 15 feet. And tractor goes everywhere in the village. 8,000 rupees is the cost, my dear friends. 8,000. With 8,000, if you can give a lifting facility in the village, imagine what kind of a happiness the village gets it. People get it. Now today, कोई लोड की गाड़ी आता है तो आदमी आए तक गाड़ी ऐसे खड़ी रहेगी. और लोडिंग के लिए भी प्लेटफॉर्म चाहिए, कुछ चाहिए. All kinds of skilled people are required. It's not easy to load, unload anything, machinery, motorcycles, anything. But this can do anything. Now, that's a kind of unmet need we can do it. Affordable, appropriate, and health-wise, environment-wise, energy-wise, you should be able to handle it. That's the way you must focus. Next. I have a few more. And weaver, you know, handlooms. We have 24 lakh looms in the country. Out of them, I think 60% are women operating. I didn't know this. 60% women operate looms, and they operate legs operation. Every operation means 25 to 45 kg lifting, depending on type of loom, jacquard or non-jacquard. And they do 5,000 times a day. Lifting 45 kg 5,000 times a day. Try and see it. After 1 or 2 hours, they get up and walk. They come back. At the age of 40, they stop weaving. 40, 45. Knees are not helping. We lose that wonderful experience because after 45, they're not doing it. But this boy, click both. This boy made a small equipment, Bodha Shiva, put it down there. You see it down there. Purely electromechanical. You touch the pedal, just touch the pedal. Don't press the pedal. It operates everything. Load from 25 to 40 kg came down to half a kg or less than that. 11,000 rupees is the cost for non-jacquard, 20,000 for jacquard looms. One time cost. Three benefits. A, those youngsters who are doing today, they did not think of retiring from handloom. They can work till they go up. B, elders who have retired from the handloom can come back and do it, and their skills, their absolute fantastic experience can be shared. They share with all of us, and more livelihood. And 3, the boy on the right, you see, he had no legs. And the person weaver, no legs, he cannot think of weaving, and they don't know anything other than that. So for those people also, they can do this. Such is the benefit of a simple electromechanical 11,000 rupees pedal machine. Now that's what I think science and technology have to look at it. There are people. Next. So I hope all those things we talked in the beginning, I find from these innovations, there is a pain removal, therefore happiness comes. There's appropriateness. Less energy consumption or no energy consumption. You know, in the villages we have 5 sources of energy. Human, cycle, you can call motorcycle now, then sun, wind, biomass. But what we have given to villages is diesel, petrol, electricity based instruments. We have just ignored their source of energy. We've given only what we know. Our generation did wrong things. You don't do it. Correct it. Give them what they have. Use the local resources and leverage that. Then you will be really doing a benefit to the people. Strengthen the strengths. Don't fill the voids. And you can strengthen the strengths only when you know what are the strengths. Then the emphasis is on people and happiness, not on technology. You don't carry technology and say, look for the problem. That's wrong for the masses. Because again, I say nature is customized, technology is standardized. You have to choose technology, appropriate technology. Having understood the problem, having described the pain, define the problem, then choose technology which is appropriate, affordable. Then only you'll be able to help them really. Okay, I think affordable excellence is a very important word. हमारे commercial world में बोलते हैं कि capitalist country में more you pay, more you get. 5-star culture, 7-star culture. क्यों? गरीब आदमी को अच्छा क्यों नहीं मिलना चाहिए? Why should they get it? ये सवाल we have to ask ourselves, what is wrong if born in a village? Can we give it? All of us, scientists and engineers, can we give affordable excellence so that it comes back to all of us? So the nation gets it. The input costs are less and it gets higher productivity. Who is benefited? Not individual. It's the community. It's the nation. I think affordable excellence should be one of the design criteria for everyone who is making something for the world. Okay. Their health, they're very conscious of their health. All the innovation, what they make, villages make for themselves, 95% do not affect their health. And that's what we have seen over a period of time. One odd cases, maybe that's why 90% I said it. So all the accounts of the theme of a conference creativity at the villages is already by design or default is working a lot. I think we have to emulate them, learning from them, and put it in our science and technology so that the world, the nation gets benefited. Next, please. Oh, I told unmet needs. Next, last slide. So I leave it to you to read it instead of I speaking about it. We must start respecting people. We think that when you go to village, we start giving them, as if we have a lot of ahankar, a lot of things we have, and we know everything. No. I was walking in one day in Araku Valley, and one French journalist was walking with us to cover the journey. And we saw sheep coming, lots of sheep coming in front of us. They looked at it, he says, Brigadier, they all look same to me. I said, they're not same because shepherd can identify. He didn't agree, and we talked to the shepherd when he came forward some time. So when he asked the question in Telugu, he looked at the Australian, French guy, and borrowed a book from his hand, opened the book, and showing the letters, he says, they all look same to me. For him, sheep is not same. For him, the letters are same, because he cannot distinguish between them. He is good at his knowledge and his creativity. We are good at our knowledge and our creativity. Why are we comparing that he doesn't know anything, only we know? I think it's wrong. Every person has his knowledge, God given, you and I have not given, sanskar given, environment has given. Without knowing all this, we say, he doesn't know anything, we'll start telling them. Please, when you respect them, you win their trust. When you win their trust, communication comes up, knowledge is shared, lot of interesting things come up. But you shut yourself and think that you know everything. Grassroot Innovations never share their creativity. And this country needs creativity of people, because it is nurtured from the nature over a period of time and used. In fact, we are surviving because of the knowledge of their people. So please remember this truth, and I request the generation behind to be more serious on what we have within us, within the country. Use that and then build. Development cost will be less. Thank you very much. Next slide.
Thank you so much, Brigadier Kanchan sir. I wish you could have come with your complete team here. All those people who have been involved, really. Sure, no problem. But then we need such occasions like that. And of course, well, that's very nice that he has given his lecture, his eye opener, and I'm sure a lot of students sitting here. Message conveyed is like that science is not only for those people who study in the class in science. Science is around you everywhere. Whatever you do, there is a science behind that. It's not magic, and you have to think it over. That's all. So you use your brain, think it over. You'll get creativity. You'll get innovation. Thank you so much, sir. And I think we have to honor him with. Oh yes, if you have, I think that's very nice. Please have a question, because this is first this lady. Okay, yes, I think so. You could come. Right?
I think questions are important. Shawl is not important. Yeah. Yes. Give a few minutes. This is important. Questions.
You talked about the VD that is applied in the herbal VD that is applied in the paddy fields. So what is the timing at which it is applied? Because you said it kills the seeds of the weed.
Okay. Yeah, it is about 4 liters per acre. 4 acres per liter is recommended, and that is to be applied a day before transplantation. One second. A day before transplantation, and churn it. So that the entire, it has to be mixed with sand and put it in the field. 4 liters per acre a day before transplantation. And then churn it with your, whatever the machine tractor you have, churn it. And next day to transplant your paddy. and 20 days, ensure that there is at least 1.5 inch to 2 inch water in that. Afterwards, you see what you saw in the right side one. Nothing, not even a single wheel comes. It's available. Women can contact me. I can connect the innovator and you can take it. Anybody who wants to do it. Yes, sir. One girl.
Sir, first of all, it was really inspiring, the entire presentation, all the innovations and everything. In fact, I used to work as a journalist. I have covered one of the innovators that you have mentioned here. So it is truly nostalgia for me all along. Based on what you asked about all the students here, so I'm very sure many of them might be inspired by what they saw. So, sir, the Pandey Srujana here, this organization, is there any framework for which like the students could actually reach out and, if possible, join with these innovators? Like, is that some kind of framework that your organization has?
What's your name?
Lakshmi Priya.
Lakshmi Priya. You see, good work needs good people and needs more good people.
That's it.
And they must come on their own. Then only good work continues.
Absolutely, sir.
So all those who want, they will reach me because I showed the number.
Absolutely.
Otherwise, they will ask the organizers, then they will reach me. Let's not force them. Those who can come, they are good enough. 5 are good enough from this lot. 1 is good enough. Instead of telling all you must go self-us, don't make it. It should be voluntary. Serving society, ensuring people around ensuring people around you live in a better way. Do you need a mandate? You need to be. It's a role you have to play, my dear children. And if you have not showed you that role, it is our fallacy as elders. We have not given you the role model to you. You must not alienate yourself from society. You must engage with society. Unfortunately, education alienates you from society. Ensures that you are alienated. And you become a scientist, engineer, and a capitalist, totally alienated.
Thank you, sir.
Did I answer your question or I bullshitted you? Yeah. Yes, sir.
Many thanks for a brilliant presentation. I just have a small query. You see, you are aware of the fact that parali burning is a major problem in Punjab and Haryana and the Delhi NCR region, because of which we face a lot of breathing problems from the month of October onwards till about December. So have the governments of these regions or the farmers of these regions approached you regarding the harvester combined innovation which you showed us?
Yeah.
If that becomes very common there, then the parali burning problem will vanish and they'll not have to actually, they are spraying all sorts of things and they are just, paying the farmers to not burn parali, and it's leading to a lot of wastage and air pollution in that area.
Thank you, sir. That's why I highlighted this for all of us to know. 2015, he was awarded President of India Medal. The jury committee was headed by DG ICAR. And then he got a patent later. But till today, the technology available with the Department of Science and Technology, Government of India. Transfer of technology is ready for anybody. Now, I wrote letters to Prime Minister, Agriculture Minister, Arvind Kejriwal. Now I am writing to all the MPs, all the MLs of the entire country. That isko leke aao. How to bring it? Simple. Existing machines to be modified within the next 2 years. Otherwise, they are not no license to run. Give them time. And new machines from now on will incorporate this, or if not this, better than this. Farmers love it. The country loves it. All of us, maybe it should be resolution of IS 45th Indian Social Science Congress, make a resolution and send it to the government if it is permitted by the committee.
Very, very good idea. But what is their response when you wrote to them? What have they said to you? Have they taken steps?
I'll share the correspondence from the PMO office with you. They put on the side, they put on the side, they put on this, put on this. ABCD, avoid, bypass, confuse, defer. That's what bureaucracy does.
No,
I work with bureaucracy a lot. They don't just defer it.
See, our honorable...
Point is, maybe I have not conveyed the way it should have been conveyed. I want all of your support. If you believe it, whole things are available with the Department of Science and Technology. National Innovation Foundation has entire technology.
No, but I am told that the Honorable Prime Minister takes personal interest in these matters.
He did, and he shared this letter with somebody in the Agriculture Department.
And there it lies.
There he gave a reply which is tangent to what I have written, and I wrote reply. He didn't like my reply because it was not in consonance with his thinking. You know what happens to bureaucrats? They don't like it. So we have to do something better.
So it's gone into cold storage.
No, I failed, but I have not left it. We all need to push it. In next 2 years, we must ensure that farmers get benefited and no halla gulla. They made a baler. Nonsense. Create a problem and solve another problem. Yeah.
I think a resolution must be passed to this effect. Yes.
Chaubeji is standing, sir. Can send the mic to him, please. Please pass on the mic. Sir, louder. I can't hear you. My mic on. The mic on karo.
I would like to inform this House that Government of India and the Prime Minister will never do what our scientists suggest creatively, simply because those who are operating these machines technology, they are managed by the companies, imported technology and others, and their design is to kill the science and technology here, not to improve it, no matter what you do it. So acknowledgement and public announcement of the Prime Minister is just for public consumption. Now what I would suggest here is, and that is why I requested Brigadier Ganesan to come here and put it, that this kind of thing, if it has to be promoted, it has to be promoted by Indian Social Science Academy members and form a collective group of people who can undertake this. It can be done in Punjab. People of Punjab will join it if you create a cooperative system of manufacture doing things. Government and Kesari, what is this, the Chief Minister of Delhi, Kejriwal, is also a representative of a corporate world. The name of Aam Aadmi doesn't mean he's a Aam Aadmi. So please do not get misled if you are a scientist or if you want to be a student of science, that no matter what you do, and first of all, you will not be allowed to do any good research. The way you are taught, it is not creatively. You are never taught what science is and how you can be a scientist. You are only sucked into the system in a manner that you don't become creative. Now, what Brigadier Ganesan has been doing for last several years, by going to villages all over India and demonstrating that science does not grow in laboratories. Science grows in open societies. And if you are cut up from we used alienation. If you are cut up from your society, from your people, your life, by reading books and looking in microscope here, you will not be a scientist by any means. It is impossible. But that is what the system, those who are managing India, they have been pursuing the colonial system of education and research, not in your language, in English, which you don't understand. Does any one of you dream in English? None of you dream in English. Then you, and you are made to read books in English. And I find here things. So,
Sir, can we give a chance to other speakers, sir?
Okay. So my submission is let us resolve that we will pursue it.
Yes.
And next year the theme is such that we will pursue it and go to villages, farm people, and then that will work.
Children, anybody questions before Dr. Vikas Gupta asks questions? Yeah, please. Take mic.
We will ask question from.
Give it.
Yeah, thank you, Brigadier, once again. That's fine. I mean, okay. Through your presentation leading up to the responses, in fact, from Dr. Chaube, I'm quickly reminded of this question posed by Jairam Ramesh once we gone to meet him. And we said that what is this nonsense of giving one single textbook for one subject for the entire country? And he said, why not? I mean, I can still understand for languages, but why not for science? Now, when the science grows in the society and society is full of diversity, this symbiotic relationship between learning in the schools, that is what you talked about also, the symbiotic relationship of learning in the schools with the outside society is immediately broken when the science textbooks are written in one language for the entire country. That is what the NEP 2020 proposes. In one language for the entire country, and then to whatever degree translate it, and not necessarily in all the languages. So I really think that, because we had, I think, some panel on education as well, and since in the Social Science Congress has this idea that we learn from different sessions, we will really deliberate somewhere and write to the government as scientists, that this whole idea of introducing nationwide single textbook, is against the idea of science itself. Yeah. Thank you. Thank you. You're always, exciting.
Thank you so much. That's really great. And of course, NEP. This is the last question, because otherwise I can't.
We'll come to the youngsters if they want to ask. Otherwise, meet me in the lunch and talk.
Okay. Here I'm talking on behalf of all the youngsters. Yes. Among the plenary sessions so far, so this is the session which covers all the three titles appropriately. All the inventions which are environmentally friendly, which consumes less energy and strengthens the health of the people, very particularly in the farm sector. So really kudos and apropos for completely coordinating the entire things. A leader is supposed to be like this. And the other thing is, I am also doing little bit of the IPR work to my students. And the students here, because you have walked a long path and you have got a good number of experience, you kindly help the students put in a few words how to bring out their ideas and get a patent. Like that, in that all our students are really very brilliant and they are having the potential scientist. I'm damn sure. So your experience kindly help them.
Okay, few
Thank
minutes.
We make a group.
So, friends, basically, as I told you, the chart about peace of the world, you must look around, observe the pains and problems around you. Make a habit. Don't worry about solutions. And there is so much around you. In a house, your mother, your grandmother, your father, neighbor, everybody, whether milk wala, paper wala, they all have problems. And in the problem, observance of the problems is the first stage. All you have to learn, wherever you are, whatever you are doing. You not be engineer, scientist. Young or old, doesn't matter. And once you make it a habit to learn the problems of society and list them, or sometime the low-hung problems are over, low-hung fruits are over. Then you go deep into society.
Right, sir. Thank you so much.
One
I'll
second.
request the secretary.
That's not
You
fair.
have to honor him with a-
That's not fair. Let me finish it.
Huh?
That's not fair.
It's our pleasure to honor Brigadier Ganesha, who brought to limelight the creativity of the villagers and their indigenous technologies. It was really spellbinding, sir. May I now request the chairman of the session to do the honors?
Oh, okay. Just a small token action here. No, this is with your photograph also. We cannot take it out ourselves. So this is with your photograph.
Thank you very much.
Okay, we will send you. Sorry. Okay, thanks a lot. It was very interesting lecture. It's taken more than an hour. Now, because the time is running away, so I quickly invite the next speaker. He's already there on that, Dr. Murugan, and he's going to speak on ecology of insect-plant parasitoid interaction, with a special reference to biological insecticides for the sustainable. Oh, it's a long title, of course. Yes, of course, it's here. Please.
With immense pleasure, I would like to introduce our distinguished speaker, Professor Dr. K. Murugan, Pro Vice Chancellor, University of Science and Technology, Meghalaya, who has been identified as one of the top 2% scientists in the world in the field of mycology and parasitology, based on the citations of his research publications by other scientists. A recent research by professors belonging to Stanford University, USA, who have analyzed the contributions of more than 1 lakh scientists for their impact-making research publications in the field of particular subject, using various assessment parameters, who have ranked Dr. Murugan in the 124th position in the world. He has published over 460 peer-reviewed papers in reputed national and international journals, besides 2 books. He has graduated around 10 postdoctoral students, 55 doctoral scholars, 65 masters in philosophy researchers, and 100 postgraduate students. He currently supervises 3 PhD students, and he is a reviewer of and editor of many international journals as well. His recent citations 13,980, H index 64, and I-10 index 282, and his cumulative impact factor more than 1,000. Dr. Murugan has done many hands at ease during his impressive academic career. Formerly Senior Professor and Head Department of Zoology and Registrar in Charge Bharatiya University, Coimbatore, South India, and formerly Vice Chancellor at Tiruvallur University, Vellore. There are many jewels in his crown, and he has been awarded for his scientific knowledge and recognized from various international forums. STA Fellowship 1995 from Japan, FAO Forest Award Italy, Commonwealth Fellowship by the Association of Commonwealth Universities UK 2000, to name a few. Indeed, it's our honor to have such an illustrious academician and researcher amidst us. Now, may I now request Dr. Murugan to deliver his address.
Very good afternoon to everybody. Really, I thank the organizer for giving this opportunity. And also, I thank my colleague, Dr. Laskar from University of Science and Technology, Meghalaya. Today, I'm going to talk about 2 issues, 2 titles. One is a mosquito and its impact on human being. And the another one is butterfly. And then in this field, we are working on more than 35 years. I studied in a Madras Christian College, Tambaram, very nearby, Chennai Loyola College and Madras University. And really, whatever I am going to talk on insects, it is more relevant to the society. Whatever the insects you are taking, right from mosquito or butterflies or ticks, mites, or sericulture, that is Bombyx mori, silkworm, and other thing. And also, insect is also a very great food for human being. Knowingly, unknowingly, we are taking daily insect as a food, whether you are taking a rice or chapati, or cauliflower, or cabbage, or pulses, or any food material. So many insects are there, so that we are using insects, and insect protein as chitin protein is the toughest protein for human being. Even we can use the insect as an alternate food material for our food. All other Asian countries and other Western country people are eating insects, either live insects or cooked insects like that. First, I am going to talk about mosquito. That is, my title is a biological insecticides for the sustainable management and conservation of insects. Next slide, please. Oh, yeah. So presently, I am working as a Pro-Vice Chancellor at the University of Science and Technology, Meghalaya. Earlier, I was a registrar as well as Senior Professor and Head Department of Zoology, Bharatiya University. That is my parental university. I put 32 years service over there. So that I am a biologist, zoologist, and I am an entomologist working on insects, both harmful insects and beneficial insects. So this is the University of Meghalaya. I should thank my Chancellor, my Vice Chancellor, my colleague, since I am working as a Pro-Vice Chancellor over there. Okay, this is it is very near Guwahati, about 15 kilometers from Guwahati in the state of Meghalaya. The university is a very great university, A grade NAC accreditation, and so many other good things are there. Okay, and then students from Northeast India, and then this is the Bharatiya University situated in the Western Ghats, Coimbatore, Tamil Nadu. These students, and then students from Bharatiya University. So I am going to talk about mosquito because really Dr. Ganesham has given very good technology, real technology, alternative technology, even we can say indigenous technology. And really I am much thankful. You will be really much tired, more sleepy. Okay. And then, okay. So I am going to talk about mosquito. So before going to see mosquito, we should know the biology of mosquito, life history of mosquito.
because daily we are getting mosquito bite in the morning, afternoon, evening, night, so on. We are going to talk about and how to control mosquito, how to manage mosquito by biological means, biological insecticide from indigenous plant products like neem and other bacterial insecticide, viral insecticide, and also what are all the natural predators or managing insects. We are all going to talk about with more slides. I have more slides. Sometime it may be a slideshow for you. And then mosquito life cycle consists of egg, larva, pupa, and adult. The adult mother mosquito laying eggs, depositing eggs on the water. All kinds of mosquito. That means there are three kinds of mosquito. One is a malarial vector, two is a dengue and chikungunya vector, third one is a filarial vector. Okay? The malarial vector is taking blood in the morning. It transmits plasmodium from one person to another. We are getting malaria. Okay? It breeds in a drinking water ecosystem. Where we are drinking water, no? We are storing water in the mud pot or any other means. It breeds over there. And then egg will be laid there. Egg will be hatching in the water. There will be 4 larval stages, 1, 2, 3, and 4. And it reaches pupa. From there, adult male and female are comes out, and they are mating, and it takes blood. Here in mosquito, as you know that, everybody knows that, it is a male only, female only blood sucker. It only transmits diseases from one person to another. It is a everyman subject. Okay, everyman subject. You should know the mosquito because it transmits various dreaded diseases like malaria, filaria, and dengue and chikungunya. This is a malarial transmitting mosquito, adult mosquito. And then as you know that mosquito is a public enemy #1. And then this is a malaria life cycle. Those who are getting malaria, there are 2 kinds of life cycle. One is from human being, another one is a mosquito. So first the plasmodium, the parasites through mosquito, it enters into the human being, it affects liver. Then blood corpuscles, then again picked up by mosquito, it grows in the mosquito gut, digestive system, and such a way we are getting malaria. There are 4 kinds of malarial parasite, plasmodium, okay, 1, 2, 3, and 4. And this is the egg deposited in the drinking water, okay, the mosquito. Wherever you are keeping your water in the pot or anything, if you are not closing the lid, the mosquito will come and deposit eggs over there. Egg will be hatching, it grows, and then we will be getting mosquito bite, and we will be getting malaria. Okay, so we are responsible. We are growing mosquito in our own house. Okay, and this is the larval stages in your own house. If you are opening your drinking water pot, you will be getting this one. I think so. Okay, and this is the larvae. This is the pupa. This is the again pupa. And the breeding sites, no, the malarial mosquito is a different kind of containers, the overhead tank, and then river, and then this is a Quilex conchifaciatus, the another species of mosquito which transmit filariasis. It takes blood during night time. When you are going for a deep sleep during 1 to 5 in the night time, this mosquito will come and take bites, takes blood, and transmit filarial worm, that is a Wuchereria bancrofti, that is then we are getting a elephantiasis. Okay, and then during daytime, the Wuchereria in the night, these parasites will be available in the our free circulation, blood circulation. At the time, this mosquito will come and take blood over there, and then female mosquito, not male. Females are blood sucker. Female will be needed blood protein, and male will be a vegetarian. It takes plant secretion and nectar. Okay, and then this is a life cycle of filarial vector. Quilex conchifaciatus. The breeding site is the ditch water and sewage water ecosystem. And I already said that the microfilaria which hides in the backbone of the human being during that time. And then this is a Wuchereria bancrofti, filarial worm. This is the parasites of filarias. It transmits by mosquito through one person to another. This is a, is a disorder ecosystem, breeding size of mosquito. Is another one is Aedes aegypti, dengue vector, diabetic mosquito. It transmits virus from one person to another. There will be a 4 stages, 4 kinds of virus, 4 kinds of virus. This is a day-biting mosquito. Now, transmit virus. It affects human being, all age group, children, 1 to 10. Okay, it's the viral. Children, it will transmit to blind, so that you will get dengue hemorrhagic fever. Okay, and then this is another species, Aedes aegypti, this is Aedes albopictus. Both the species are transmitting mosquito, dengue and chikungunya. Okay, and then these are all the bathroom of village side. The people are saving water, storing water. This is a very good breeding sites of dengue vector. That is a dengue vector. Okay, Aedes aegypti and Aedes albopictus. Like that, we are drinking coconut, tender coconut. We are throwing what we will be filling in the rain. Other thing, this is a very good breeding sites of dengue vector. And then automobile tire. Automobile tire. That previous slide I have taken from Taiwan. This slide also from Taiwan. Okay, so people are aware in all over the world. We are throwing out the tires. Water will be storing. There is a very good breeding sites of dengue vector. Okay, this is a dengue mosquito, which will be the behavior, this swimming, everything will be different. Okay, in your own house you are having in the mosquito, you can safeguard your mosquito. Okay, and then this is the, so all the mosquito species laying eggs on the water, and then particularly the dengue vector, not exactly laying eggs on the water, it laying as on the rim of the container, any wet surface of the container. So the egg will be there for 1 year. The egg will be hatching after getting the rain. The egg will be hatching installment basis. In Tamil solapona, tavanai murayil muttai porikum. Right? Okay, then so that we should clean the container. Very in our house, we have a water tank. We have other utensils. We are storing water. You have to put your hand. You have to put your hand and you have to wash. You take any, even a coconut shell, any other thing, then only we can kill the mosquito egg. Automobile tire, again the grinding stone. That is also a very good breeding size of dengue vector. So the chikungunya, the another disease, the mosquito transmitting disease, which affects mainly the joint. The virus transmitted by mosquito, which affects your joint. Your leg will be bulging. You have to walk. You have to run. You have to go for a toilet daily. That is very difficult. If you are having a Western type of toilet, you can go and do your job over there. Otherwise, you have to put a rope in your bathroom. In village side, they don't have Western type of toilets. They are tying up a rope. You have to climb. Put rope, with the help of rope, you have to sit down for your toilet and other thing, and you have to climb up again. Sometime, if your hand is very wet, you will fall on the same the basin of the toilet. Okay, so that if you are talking, if you are thinking that mosquito is a very tiny, we can easily kill the mosquito. என்னமா கொசு தானே, கொசு எனக்கு பெரிய தூசு, நான் அடிச்சு போட்டுருவேன் அப்படின்னு கூட you will think that. But if you get malaria, filariasis, dengue, definitely you will be getting very tougher time. Okay, so that you should be very careful about mosquito. Okay, and then you know what is that? Moringa oleifera drumstick. It is a good food material for chikungunya, viral borne disease. You can take sambar or any other thing with put idli or dosa. You will be curing your viral disease. And then you can, if you have a chikungunya, you can eat all greens, mint, curry leaves, coriander, buttermilk, ginger, and garlic. And then if you are, and you can have a Maharaja Yoga Gugulu, is a tablets, Sirbala Thailam is there, is a kind of ointment. And also you can have a other plant material like Vadanarayana leaves and whitest nendo in Tamil Nochi. You can put crude salt, you can have a bath, then your chikungunya will be okay. And then if you have a mosquito, if you have a mosquito bite, you are going to the tour or any other forest, you can take you can mix coconut oil with neem oil, coconut oil 10 drops and 1 drops of neem oil you can put and spread over the exposed parts of the body. Don't put in your nose or eyebrow or eye inside mouth, then it will spoil. Okay, right. Then if you have a mosquito in the overhead tank, you can put a neem powder with garlic powder and mix together, put it over there. Mosquito won't lay the eggs. The mosquito larvae will be there. It will kill and also water will be purified. Okay. And then like that. And then you know neem. So Dr. Granson sir talked about various indigenous technology. Neem, Azadirachta indica, botanically, it is originated from our India. Okay, it is an antiseptic. It is a karpaka vricham. It gives you everything. Whatever you need. Well, you need a shampoo, or you need this one, or you need anything. In those days, for any, if you have a lice in your head, people will put neem oil. They will take bath. So it is a karpaka vricham. Whatever you want, you can do that, and it is a very good insecticide also. Is a very good mosquitocidal also, so that it is a very good biofertilizer also, so that it is a very nice plant system only in India, originated from India. Okay, and then if you want to have a neem based insecticide to kill the insects in agro ecosystem or kill the larvae, you can easily prepare extract that is called NSKE, neem seed kernel extract. You can make a powder, grind it in your own this one, and then you can powder 10 grams or 1 gram in 100 ml, soak it in overnight. Morning you can decant. That is a neem based bioinsecticide. You can apply the agriculture ecosystem where insects problem over there, and also you can also use your own hand. There is no need for having a brush or what is that, any sprayer, and it is already it is antiseptic, okay, antiviral, everything, and then it is a very good neem based bioinsecticide, neem seed powder. And then this neem, you already know that it has been patented by American already. And they have taken the neem seed, they have isolated a compound that is called azadirachtin, tetranol triterpenoid compound, and they have already patented. We cannot work on neem. They have taken our resources and they have patented. Now they are selling in a Sigma chemical company USA. Even 0.001 milligram is more than 25,000 or 50,000 rupees. So that the basmati rice we are eating biryani, no, they are also claiming their property. Similarly, the karkma longo, what is that? The turmeric in Friday, all girls are putting and you are taking bath, no? That is a very, very important. Curcumin is a very good chemicals are there. So that also the US people are claiming is our property. Day by day, Western people are coming and taking all the properties and they are enjoying like anything. We are always poor. India is a poor country. We are writing a letter. That is this one is there. And then we are talking about botanical insecticide rather than chemical insecticide. If we are dumping more the mosquito larvae, Problem, environmental toxicity, insect resistance, insect resurgence, so many problems in Kasaragod due to endosulfan toxicity. Lot of people are dying. Already they have a lot of genetical disorders in Kerala and also in Andhra Pradesh. Every year people are going for suicide for dumping more insecticide on the agriculture ecosystem. So that we have a lot of natural resources, lot of botanicals, we can extract those chemicals, we can easily kill the insects and other things. And neem tree, and it has various biological effects against the insects. And then these are all the main compounds present in the neem. And then this is a Pongamia. It is also a very good insecticide, boya insecticide. And then Pongamia seed, ingella pathupinga nariya ponga maram இந்த campus கூட நிறைய இருக்கு. Okay, and then it has a lot of chemical compounds. And then also for killing the mosquito or control mosquito, we are getting mosquito coil, commercially available mosquito coil. It has a what is that? A compound, chemical compound, D-alethrin is there. It from mainly from Japan we are importing. It is a very costly chemical and more toxic. So that you can, instead of getting commercially available mosquito coil, you can use the botanical base mosquito coil from neem, tulsi, tumbai, all those things. Okay, like that. Okay, like that we can make a biocoil. Nochi, eucalyptus oil, you can have it is a medicinal, it is available in India, and you can also spread oil over there. We can avoid mosquito bite. Okay, and then you know Phyllanthus umbilica, Indian gooseberry. What is that? Nellikai in Tamil. Okay, it is an antioxidant and it is a very good mosquitocidal and also very good water purification properties. Lot of amino acids. That is amino acids are there, that is water soluble. You can make an extract, you can spread in the drinking water ecosystem if you want to kill the mosquito larvae, and then the target mosquito larvae will be killing, and also water will be purified. Okay, and it gives extra flavor to the water also. Okay, நெல்லிக்காய் நீங்க எல்லாரும் பார்த்துருப்பீங்க, கடையெல்லாம் வாங்கி இப்போ எல்லாம் நிறைய போயிட்டு இருக்கீங்க. ஓகே, and then you have again our முருங்கைக்காய். It is a very superb vegetable. Daily நீங்க முருங்கைக்காய் சாப்பிடலாம். You will get extra boosting this and that. Okay, so that it is a very good tulsi. And then apart from botanical insecticide, we have so why we are talking about biological insecticide? If you are spraying chemical insecticide, it affects the ecosystem. It affects every plant, animal and everything. So that apart from botanical insecticide, we can also have a bacterial insecticide. So that if this bacterial insecticide doesn't cause any ill effect to the non-target organism which are in the water ecosystem or in the soil ecosystem. It doesn't have effect against the even what is a silkworm or earthworm or butterfly or honeybees or anything. So that we have a lot of bacterial insecticide. BTI, Bacillus thuringiensis israelensis. It is a bacterial insecticide. It is also a mosquitocidal, mosquito larvicidal. And then these are all the all mechanism of action and other thing. And you have also other kind of bacterial insecticide like spinosad. These are all the biological insecticide. If you spray over there in the water, the larvae will be killing, and you will have the other stages are floating over the water. Okay. So we have a lot of collaborative project. DRDO, Defense Research and Developmental Organization, DSD, UGC, we got a lot of fund, and especially we had a project in northeastern India, Tejpur, Assam, and because in Assam, in nearby forest area, and particularly in Assam, people are daily taking tablets. Either they are taking breakfast, lunch or dinner, they have to take tablets because all the mosquitoes are very, very infective, because more malaria over there in Assam and other northeastern area. So that we had a project, we did a lot of exercise or this thing project work, and we have made a mosquito larvicide from neem and other botanicals and bacterial insecticide. Okay, like that. We also did our tsunami rehabilitation during 2005. We went to Tamil Nadu and then Kerala and also Pondicherry and those things during 2005. Okay. And these are all the mosquito larvae. Mosquito larvae after spraying of a bioinsecticide. Like that, we made a field study in Tejpur, Assam, Northeast India. And then these are all the mosquito larvae, not a fish. Not a fish. It is a mosquito larvae. We are growing in our own house, in front of our house. So we are not cleaning our water or anything. So that we are the responsible for our mosquito. We are breeding over there. We are getting mosquito bite. We are getting disease. Okay. And then like that, all these are all the mosquito larvae. Okay. Tsunami rehabilitation at the Tamil Nadu. And then so mosquitoes are transmitting many diseases. It is very, very serious, both malaria, filariasis, dengue. So that we have to control, we have to manage, apart from using a synthetic insecticide. We made several research collaboration all over the world. From US, we had a ultrasonic device which produces sounds. The sounds will be passed in the water. The mosquito larvae will be killing. Okay, like that we done many work like that. So that like that. Apart from that, we made a work on cigarette, the cigarette waste. Those cigarette waste we are collecting, and we are making a bioinsecticide for smoking and other thing. We are using the that is a bio smoke or something like that. And we made a very good publication in a particular journal, Springer or elsewhere. And also BD, okay, Indian traditional cigarette, and we are also, the waste will be collected, that will be used for bioinsecticide, okay. And then like that, and also we are making, we are eating shrimp, we are eating, what is it, shrimp, no, you know shrimp? Yes sir, Ilangon sir, you know shrimp? Okay, yara, nalla kolmu saaprodringla. And then that one, we are removing the shell will be used for bioinsecticide. Okay, and you are using a crab in Tamil Nadu. Nandu soup on சாப்பிட்டிருக்கீங்களா சார்? நீங்க தான் எனக்கு தெரிஞ்சவங்களா இருக்கீங்க, அதனால உங்களவே நான் கேள்வி கேட்டுட்டு இருக்கேன். சரிதானே? Okay, so that shell will be, we are throwing out. The shell will be used for larvicide, bioinsecticide. We made a lot of very good publications in Springer Journal, Hydrobiology, so that it is a nice thing. Okay, and then we made a nanotechnology. Everybody are talking nano characterization and all those things. And we are also taking a nano insecticide. We are extracting nanoparticle, biofabrication, biosynthesis of nano insecticide. And then we are using as a mosquito control agent as well as insecticidal agent. Okay, it is from a bacteria. The nanomaterial will be extracted from bacteria that will be having different behavior to kill the insect system. Okay, like that, the ultrasonic sound will be mechanically killing the mosquito larvae in the breeding sites. Okay, like that. Okay, and then sometime we are also working on fungi in Tamil Punjanam. So that the fungal insecticide is a biological insecticide we are using for mosquito control and also insecticide. The fungal spores will be traveling from the air. It will be attacking, it attached with insect, either insect pest, adult insect pest moving from one plant to another, or mosquito adult that only transmit diseases, so that the fungal spore falls on the insect body. This one, and it kills the mosquito larvae, and also these fungi, this fungal organism which produce a specific toxic substances which kills the mosquito larvae. This is also a fungal insecticide. So many fungal species are there. There is a Metrology, Manisophiae, Bevaria bassiana, like that. Okay, and then this is a mechanism of action. And then we have also working on viral insecticide. So the viral spores, viral bodies will be spread in the agroecosystem. The insect system, it has different that is a mechanism of action. The infected larva insect pest will be hanging like this, ups and down, it will die. Okay. Then whatever the viral will fall on the ground, recycled and kills the mosquito larvae. Okay, like that. Even okay, these are all the fungal affected silkworm. Silkworm. Okay, these are fungal insects. You know, locust. So locusts are giving problem every year. Even India also last 3 or 4 months back, so it came from the Afghanistan and then Pakistan, then enters into the Rajasthan, and we are getting lot of problems. It is a locust, it is an insect, it is a grasshopper, which gives a lot of problem. So that it comes like thousands or lakhs. It attacks every plant system such a way it devastates the agro ecosystem. It is also an insect. So like that, sometimes it enters into the cities, and it gives problem to the human being. The legs contain a very tough legs with a lot of hooks, lot of hook-like structure which falls on our face. If we are pulling up, then our flesh will come like that. Okay, so that it is a problem, particularly in Africa. Every year it is a problem. Okay, like that is a fungal insecticide, fungal spores which affects mosquito larvae which breeds in a water ecosystem. Okay, all fungal. Aedes aegypti, it takes a human being and transmits virus from one person to another. And then Aedes larvae, and then these are all the containers we have already seen. And we are telling that everybody are working on a nanotechnology for drug delivery. We entomologists, we are working for nano insecticide for insect control. And then these are all the different characterization. And whatever the insecticide we are using is to be safer to the ecosystem, so that it doesn't affect the other beneficial organism present in the water, like fish and other copepods and so many other non-target species are there. So that we should be very careful whenever we are going for a field trial from the lab to land program. Okay. These are all the nanotechnology, something like that. And then even the insects are also a great pest in pulses, what we are eating every day, so that we can also spray neem-based insecticide or neem oil over there. We can kill the insects on the cereals or pulses. Okay. Like that. And also we can also have the teak plantations. You have a lot of insects over there, spoiling insects, spoiling the teak ecosystem. You have a larvae that is called Aeblea pura. So we can also have we should know the biology. We can control the mosquito. So these are all the neem treated insects in the all those things. So regarding biological insecticide, we have a neem, we have a what is that, viral bacterial insecticides, and the mosquitoes are transmitting diseases. So these are all the issues of this one. I think we are all free, we are all very tired. Not I am myself. Yeah, that is we please wait for 10 minutes. That slides also we will see, and then we will have a very good lunch now. Okay, sir, butterfly mosquito போடு. அது வண்டியா இருக்கு, நிறைய ஒர்க் இருக்கு. எதத்தான் அதனால தான் ரெண்டு எடுத்து பேசியாச்சு. பட்டர்ஃப்ளை நல்லா இருக்கும். ஓகே, ஏன்னா butterflies are very beautiful like girls. Okay, okay, very beautiful. Okay, we have talked about only 10 minutes, please. Nejamave, I am talking very seriously and frankly. Hearing talk is very tough. Delivering lecture is very easy. உட்காந்து கேட்கறது ரொம்ப ரொம்ப கஷ்டம், எனக்கு நல்லாவே தெரியும். அதனால நீங்க ஒரு 10 நிமிஷம் இருந்தீங்கன்னா we can see our butterfly slides and we will have this one lunch. Okay. And India is one among 10 mega biodiversity country. We have a Himalayan biodiversity, Western Ghat biodiversity, Eastern Ghat biodiversity. You know, Western Ghat starts from Gujarat, Maharashtra, Karnataka, Tamil Nadu, and Kerala. It's a stretch of mountain. It has a different strata, different unique ecosystem. It has several plants, animals unique to the particular system, and a superb environment, both flora and fauna, plants and animals. Similarly, what is that? Eastern Ghats ecosystem. Eastern Ghats. It starts from Orissa, Telangana, and two states, new states, and Tamil Nadu ends. It has their own ecosystem. Then Himalaya, and then it is a very superb. So that the butterflies is a very superb organism, superb colorful insects, beautiful insects, and India has got a lot of biodiversity rather than other countries. Okay, and then it is a very good important. If you talk about pollination in Tamil, Magaranda Serkainu solluvaanga. Pollination, we are all think that honeybees, birds, bats, and other pollinating agents are only doing this business pollination. No, butterflies are also equally pollinator. Butterflies depended plants. Butterfly depend the plants depends upon the butterfly pollination. Only depends on the butterfly pollination only. So butterfly can only pollinate those plants, those ecosystem, either in the forest or any other, even in agriculture ecosystem. So that butterflies are also equally very important, because butterfly has a very long mouth. I am going to show all those things. Long tube. It is called mouth, no? Mouth parts, one of the mouth parts, like our tongue. And butterfly can only insert its proboscis into the flower, then the plants gets pollinated. So butterfly is a very important. It is a butterfly are also equally pollinator, and it is a very good environmental indicator. Very good environmental indicator. Through butterfly behavior, we can judge the environment. We can predict the environment. There is a superb organism. We Indians, we have to respect the butterfly. We have to grow butterfly, more flowers, more flowering plants, so that we are all think that again, if you talk about butterflies, butterflies are only taking nectar. Not like that. During their growth, during their life history, during their growth, it feeds several plants, several dietary plants. We can say several host plants. Okay, so like what is that? Mosquito. Here also the biology, the life history of butterfly is very important. Here also the adult mother in the sense the female butterfly laying eggs on the tender leaves of the host plant. Tender leaves. Okay, and then the egg will be hatching. There will be 5 stages. In what is that? In diphtheria and mosquito, it has 4 larval stages which are in the aquatic mode of life. But here is this adult butterfly laying eggs. Egg will be hatching. There will be 5 larval stages, 1, 2, 3, and 4, and 5, and reaches pupa. From the pupa, both the male and female butterflies are coming. So that during younger stages, the butterfly larvae, we can say young ones, having a cutting and chewing type of mouth parts. There are several things, about 5, including hypopharynx, that is called tongue. Okay, but after reaching the pupa, from the pupa, the butterfly will be coming newer forms with the sucking type of mouth parts, like Ganesha. Like Ganesha has a long, the elephant, this thing, no? Like that it is coming. It is a very fantastic phenomena. Is only in the butterfly ecosystem, butterfly species. So that it is a very superb, and all children will be much impressed. Even in our Aringarana Zoological Park, previously one of my IFS officer, Dr. Krishna Kumar was there. He was my PhD student. He did PhD. He is IFS. He retired as a principal conservator of forest in Tamil Nadu. He also developed a butterfly garden over here. And also earlier, we have a butterfly garden in Trichy. We have a butterfly garden in Taiwan, Singapore, Netherlands, all those things. Okay, sometime our campus will be a natural butterfly garden. Maybe our Crescent University, Institute of Science and Technology. If you plant all the plants in our campus, butterfly all will come. All butterflies are coming and taking a nectar. Some butterflies are feeding over there. All will be very fine, superb, colorful. It is a natural zoo, natural butterfly garden of Crescent Institute of Science and Technology. Okay, okay. Now so that only slide. So don't worry about that. The tukam, that is called sleep, won't come. Okay. Even our elder senior professor also won't get sleep. ஆஃப் பண்ணிட்டீங்களா? டைம் ஆயிடுச்சு, நீங்களே ஆஃப் பண்ணி விட்டீங்க. இல்லைல்ல, ஒர்க் ஆக மாட்டேங்குது. இந்தாங்க, இதா இல்லையே, ரெண்டுமே ஒர்க் ஆகலையே. சார் வேற ஏதாவது மைக் இதை முடிக்க போறோம் சார். Okay, I already said that butterflies function as sensitive indicators of environmental change. They act as flagship species for nature conservation. Okay, and then this is Bharatiyar University. They have so many rose garden, all for female only. Okay, and then several students. I used to take all photographs of mine, both mosquito as well as this one. I only taken my own photograph only. I am showing to you. Okay, and then Roja Thotam. Okay, and then போயிருதுங்களே, ஏதோ கொஞ்சம் ப்ராப்ளம் இருக்கு. நீங்கள் கூட ஆப்ரேட் பண்ண கூட பண்ணுங்க, இதுலேருந்து கூட அது பெஸ்ட்டு. அவ்வளோதான். ஆமாம், இதை வச்சுருவோம். கொடுத்துட்டேன். When I submit my abstract to this conference, our conference people told that, sir, don't present any particular subject. You talk about your 35 years experience. Like that they told, but I have taken only the mosquito, and otherwise so much of now only no time. So Western Ghats, it starts from Maharashtra. Next slide, please. Next slide. And then if you want to study the butterflies, you should know the larval host plant selection, because the life history consists of egg, then larva. The larva will be the larvae, the younger ones will feed different food material. One butterfly larvae feeds 100 plants. 100 leaf stages, we do not know. So that in order to conserve the butterflies, in order to safeguard the butterflies, we have to conserve the first plant system. Okay, that is a very, very important. Okay, even in your house garden, you can make a butterfly garden. You can choose all those things, no? Then daily butterfly will come. Butterfly come and take nectar. Butterfly larvae will feed. It's a superb. This one. Next slide. So the previous slide, please, sir. Brother, munadi slide podunga. Okay, so that we are going to talk about very briefly larval host plant, how larvae are feeding on a different host plants, how adult butterflies are taking nectar from different flowers, and then how the adult mother laying eggs on a different host plant. These are going to see. And then during their life history, apart from taking nectar, the adult butterflies, some group of butterflies are taking salt in the environment, salt in the moist environment, salt in the falls, salt in the river beds, and that is a very rare salts like aluminum, magnesium, zinc, and all those things. The butterflies are taking. That is also a food material. There, the male butterflies are only taking those material, and that material will be stored their own body of the male, and it transmits to the female while mating, because male doesn't have that kind of feeding behavior. But this is an ecosystem. This is a nature. So that we are not independent, we are dependent. Both male and female are dependent. We are getting something from madam and something from sir. Sir is having pocket money, amma is having food, so that we are dependent. Okay, so that also we are going to talk about very briefly. And also adult juice sucking behavior. That is also a very, very important. Some group of butterflies, apart from taking nectar, it takes juice, plant secretions, different plant secretions. That is also a food material. Apart from nectar from different flowers, that also we are going to see. Very interesting, very much interesting. Okay, okay, next slide. Okay, so for food selection, we also, the physical nature of the food is very important. If it is a idli, very soft. If it is a vendakai, very soft. Like that, vendakai la orusu paathu vaanguvom. Adu mari, it is a very, very important. And also chemical aspects of food also very, very important. Okay, like butterflies are also choosing like that. Next slide, please. So butterfly is a very good pollinator. Thanni. So next slide, please. எல்லாரும் ரொம்ப கஷ்டமா இருக்காங்க. Nilgiri biosphere. It is a very great forest mountain. It belongs to Western Ghats. It has a lot of butterfly host plants, butterflies, and it is a superb. Next, Silent Valley near Coimbatore. It is in Kerala. It is a virgin forest. Elephant to insects, bacteria is a virgin forest. You can visit. It is a superb place. Next slide, please. And is honeybee also one of the pollinators. Next, and butterfly life history: egg, larvae, pupa, and adult. Next. And then butterflies are taking nectar from different flowers. Okay, next slide. Butterflies are having, I told that the mouth parts, proboscis, you can see through that, it puts into the flowers and gets pollinated. Next. And then bats, also very good pollinator. You should give respect to the bats also. Next slide. And then birds, also a very good pollinator. So much of populations are in our India. So it is a very great, India is a very great country. Next. And then other bumblebee and many pollinators are there. Next slide. And then again Bardiyar University. Next. Next. Vanga. Next. Okay, we are going to see certain group of butterflies, the life history, egg to pupa. Next. Next. We are going to see the family Poplianidae, which is having solitary butterfly. Okay, it is called Popliopolitus. Next. Next. Next slide, please. So it has several larval host plants. Larvae feeds one of the Muraya conigae, that is Carivepilla. It is also a leaf. It is also one of the dietary host plant of butterflies. Next, that is called Todalia asiatica. It is also another host plant for butterflies. Same butterfly. Next, Citrus lemon. It is another butterfly, another host plant of butterfly. So I already said that butterflies are laying eggs on the tender leaves of the host plant. Popliopolitus laid eggs on the Todalia asiatica. Next. And larvae. Next, larvae. Every stages it molt, it removes its outer skin, exuvia, it gets into the next stages. Next slide, please. Molting is a very, very important for butterflies. Next, larvae, pupa, and then next slide, please. Vanga, pre-pupa, adult. Adult, I already shown first. So the another group of butterfly is called Priodos minus. It is called southern birdwing. It is it laid eggs on the tender shoot of the host plant. Next. And then is a larvae. Next, pupa. Next, adult. Next slide, please. Is another butterfly species laying eggs on the tender leaves of the host plant. Next, larvae. Larvae again, pupa, adult. Next, next slide, please. There is no data. Data la panna poradilla. Next slide, please. Larvae is a Popliodomalius. Is a citrus butterfly. Taking nectar from the what is plant? Okay, okay, hibiscus rosa sinensis. This is another group of butterfly laying eggs on the plant. Okay, next is a two host plant, 1 and 2. It feeds over there. Next, lay eggs. Next, larvae like this. It feeds. Okay, next, and then pupa. Next, it gets pupated and it removes the eggs again. This is a pupa. Okay, next, so after pupation. Okay, next slide, please. Larvae. And then adult. Next slide, life cycle, egg, larva, pupa. Okay, next slide, please. Is another group of butterfly, Danaeus crassipus. Yeah, beautiful butterfly. There are 5 species of butterflies are there. And then it feeds a toxic plant. Toxic plant. The larvae will feed a toxic plant which has a toxic substance like cardiac glycosates. Next slide, please. Next, it feeds a Calotropis gigantea. In Tamil, Erkalai. It contains latex, milk contains cardiac glycosates. Next slide, please. And then is the egg. Egg will be laid in the tender leaves of the host plant. The Danaus crassipes, very beautiful butterfly. Okay, next slide, please. And it feeds calotrophes, and then it feeds young leaves, same mature leaves, senescent leaves, and also inflorescence. In Tamil, malakothun solvanga. It feeds over there. Even though it is an adapted species, it has a certain feeding mechanism. When it feeds on inflorescence, it need a optimal amount of cardiac electrolysis from the main plant, so that it prevents such a feeding behavior. Next slide, please. The larvae feeds on inflorescence of calotrophes. Next. And then when it feeds leaves, it won't disturb the main vein. It make a small pit in order to it prevent the it prevent the milk flow from the main plant. Next slide, please. Like that. Next slide, please. Pipa, the same Danaus. Next. So the another group of the family Lepidoptera contains butterflies and moth. Butterflies are diurnal. It comes during daytime. The moths, the wings are dull. It comes during night time. Okay. So egg of the one particular species of moth which comes during night time in Nerium oleander, Tangarali. Next. முடிய போறோம் சார், 5 நிமிஷம் முடிக்க போறோம். இல்லைன்னா அவங்க படம் எம்ஜிஆர் படம், சிவாஜி படம், ரஜினி படம் மாதிரி இடையில விட்டணும். ஏன்னா டூயட் சாங்லாம் இனிமேல் தான் வரப்போகுது. ஓகே, நெக்ஸ்ட் ஸ்லைட். This is the larvae which feeds on Nerium oleander. Very big larvae. நீங்க டெய்லி பூ பறிக்கிறீங்களா சாமிக்கு, அந்த பிளான்ட்ல இது சாப்பிடுது. சூப்பரா இருக்கும் பார்க்கிறதுக்கு, ஃபீட் பண்றது. ஒரே நிமிஷத்துல ஒரு பெரிய ட்விக்கே காலி பண்ணிடும். கடகடன்னு கடிச்சிட்டு வரும் அந்த மவுத் பார்ட்ஸ்ல. ஓகே, நெக்ஸ்ட் ஸ்லைட். எக் வாங்க, நெக்ஸ்ட் ஸ்லைட். அது இன்னொரு larvae which feeds on Nerium oleander. இன்னொரு butterfly larvae. Next slide, please. This is a larvae which feeds on inflorescence. Very beautiful. Next slide, please. Next slide. And then pre-pipa. Next slide, please. These are all the Western Ghats, Southern India, Sirwani hills. It is a super. You got to visit this all our North Indian brothers and sisters. You got to come to Coimbatore. I will also lead for a tour, and it is a superb. You have to visit Sirwani. There the Jaguars, they are also there. Isa, you have to see. Very nice thing. That is a Sirwani. Next slide, please. Lot of host plants, lot of butterflies. Anamalai Hills. Nilgiri. Next. Biosphere. Next. முடிய போறோம், 5 minutes தான். Next slide, please. Okay, the butterflies are taking nectar from 1 flower to 100 plants. Different butterflies. Next slide. These are all the larval dietary plants, particular species. Next. Yes, please. Another group of butterfly which takes food as senbagapu and manoranjidam plant irukklingla. It takes those plants used as a larval host plants. Next slide, please. Like that, larvae, pupa, adult. Next slide. Next. And then larvae of this one, pupa, and this one. Next slide, please. Adult. Popular polynestor, super Ashlokia indica is a butterfly species. Larvae of citrus butterfly. Next. And then this is Thiruvalluvar University, which is situated in Vellore, Katpadi, where I was a vice chancellor for 3 years. I made a very good herbal garden with 200 species of plants. Still it is there. If you go to Tanga Koil, is a golden temple also there. Very nice. Sakti Amma is there. You go there and visit, you will get a lot of blessings. And where I did a herbal garden. Next slide, please. Like that, I made a bore, I made a watering, and I made a superb this one. Now people are enjoying taking a lot of herbal plants over here. Next. Like that, Thiruvalluvar University, I made some design, Thiruvalluvar stone, and I made during this period, my period. Next slide. Like that, herbal garden. Next slide. I also make apiculture. Okay. Next. So we made a honey. Okay. The honeybees are taken nectar from herbal flowers. So we are the texture, color of the taste also different. The honey, no. Next slide, please. Like that. Okay, it is going on. Okay, next slide, please. Next. So these are all the another insects. We doesn't bother. Now we next slide, please. It feeds calotrophes, grasshopper, painted grasshopper. Next slide, please. Okay, next. So next. So we are going to, I already told that we are going to take only 2 minutes, so that the butterflies are taking nectar. Some group of butterflies are taking plant secretion, juice, plant juice as a dietary resources. Like that, the denied group of butterflies are taking juice from a Crotalaria redisa. In Tamil, it is called Salangi sedi. Next slide, please. Okay, next slide, please. Next slide, please. Okay, like that, butterflies are not taking nectar, taking juice from the plant. Next. Here also, the male butterflies are taking juice and transmits to the female. Whatever the chemicals taken from the plant, it's sequestered. It's stored in the body and it transmits to the female. Females are depending male for this kind of food material. Next slide. Like that, butterflies are taking juice. Next. Next slide, please. Next. That's all. Butterflies are taking juice. Next. Juice. Juice. Okay, next. Next, please. Next. 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 Okay, like that. Come. Please come, sir. Okay, okay, next slide, please. So, next, butterflies are taking juice, so that some group of butterflies are taking salt from the environment. That is called salt-taking behavior or puddling behavior of butterflies. Here also male butterflies are taking. Only we are finishing within half a minute. Next slide, please. So, butterflies are taking salt. Next. Butterflies are taking salt. Okay. Next. Butterflies are taking sometime in the food material, in the animal excreta also. This is a dog excreta, fecal matter. From that, the butterflies are taking nutrition from there. Okay. Next slide. Like that, dog excreta, butterflies are taking nutritive material. Next. Okay. Butterflies are taking food material. Next. Okay, that's all. Okay, next. So sometime it's a symbiotic relationship. Sometimes the butterflies are taking salt from the turtle water, eye water. One side, the butterflies are taking food. On the other hand, the butterflies are cleaning the eyes. Such a way it benefits to the turtle. Over. That is over. Still many slides are there. No time. Okay. No time. Sir. Okay. Sorry, madam.
Thank you so much, Dr. Gum. Yes, he had, of course, he's scared in the beginning with a lot of mosquitoes and all that, but then he ended with the beautiful flies and butterflies. We have seen that. Thank you so much. And I would like to take up a couple of questions only. Just two questions.
No, sir. All are understood, sir. No problem.
No. If you have a question or you want to take lunch.
If you want to, please ask us. Please.
Well, I think they will ask you the question in the lunch. Sir. No, they will ask during your lunch time, I think.
Yes. Thank you, madam. Thank you.
Thank you, sir, for your innovative session on miraculous herbs and herbicides and Indian biodiversity. May I now request the chairperson to honor Dr. Murugan.
Okay, so please come here in the center. So thank you very much. This is from the organizer. Right. Thank you.
Thank you,
Okay,
sirs.
so this is the one also.
Thank you, sir.
Thank you. And now, Aniki, I think we close the session. We break for lunch. Any announcement?
Thank you to Chair for conducting this session and speakers. Brigadier P. Ganeshan gave a wonderful scenario about what the rural entrepreneurs they are doing, and one should love to go and see those things, how some positive things are happening in the country. We have another speaker. You enjoyed the lecture with butterfly and insects. Now we are going for lunch, and then we'll go from there to respective parallel sessions. We'll reassemble here by 5. We have a public lecture by R. Srinivas. So please join lunch. Thank you.